Yeah, very good afternoon. Good afternoon to all ones and all. So this is being the get through questions session. It is being the very useful to you people. Thing is that one is the power, you know that one power system is being the very vast subject. So in this what's happening is what is the data types are being presented. As per that what's happening is the questions have been framed right from this one is. So let us see, one thing is that we will go for this is the subject of power system. Now let me introduce these things is that one is the content what is coming in the power system are certain basic principles are required, okay, power generation and economics. So you know one thing is that one generation of the power and what is the economical featurings, and the transmission and distribution is the next module, the generated power to be transmitted and then distributed, and design of power system, okay, how to design the power system network, and then what's the power system operation control. After the design is over, the next activity is the operation, and then what's happening is the control. Then what's happening is the stable operation is required, and the fault analysis you are making to design the equipment of the protection system, and power system protection and switchgear, HVDC, HVAC. These are the modules that you can have. Is to go through all these modules, okay, you require certain kind of the introductory basics and all. So these are the regular things that we are going in the class and all the things. It is just a briefing to you. Now moving on to the questions once, and from the basics, we came from the basics. The classification of the topics has been given as per the topics they are classified. According to that one is I designed the numericals. According to that, let us go for the first question, that is a power of 10 megawatts is be transferred from source to the load through the impedance of J40 ohms. The voltage at source is 66 kV and at the load is 60 kV. Find the necessary condition for power transfer. You say, for all you people, I am requesting one thing is that one is get ready with yourself with some papers and as well as the calculator. The paper and calculator should be there itself, so that what is happening is you could be able to make the things is along with me, you also make the calculations, okay. So therefore what is happening is, as it is being the live session, so that is the reason what is happening is along with me, if you also done these questions, then what is happening is you can cross check yourself at what exact what kind of ability that what you are having is, okay. मेरे साथ साथ आप भी करो, आपके पेपर्स और एज वेल एज कैलकुलेटर एंड पेन रखा करो so that what is happening is, so it is the first question, okay. First question, it is the its subject is the power system. Power system is the main objective of the power system is that one is the transfer of the quantities from one location to other location. So for the transfer of the quantities, which quantities? Active power and reactive power. Subject of power system it is being, every subject is having its own kind of objectiveness. So as they are having, suppose network analysis is being there, nodal voltages and as the branch currents, control system, stability, machines, torque and EMF. Likewise what is happening is every subject is having certain objectives. Likewise in this also the objective is to transfer the powers. So therefore what is happening is for the active power, reactive power to transfer, we need certain kind of the power flow conditions. So as per this question has been designed. So given nomenclature of this one is a source and load. These are the two components. What is the power system? Power system can be briefly fundamentally is explained as the combination of the generation and as well as the load, that is the source and load. So as per this, the question has been given here is, this is the source that what you can have is, and it is transferring the power with an inductive impedance of a certain value, and what is this one is, here it is the load. Mind one thing I am saying, that one is load is always requires the constant voltage at zero phase. So that is the reason what is happening here is load is always be represented as a DC source. In most of the standard textbooks you can observe one thing is that one is load is always represented as a DC source. The reason for that one here is load is always require the constant voltage at zero phase. So what it is being given here is, it is given that one is, it is 66 at an angle of delta and it is 60 at an angle of 0, and here it is, what this one is J40 ohms, and the transfer quantities what are being, that one is active power and as well as the reactive power. So PQV delta are the four basic quantities in the operation of the power system. Okay, the power system is being concerned, जैसा कि गाड़ी के चार पहिया होते हैं वैसा है कि power system में भी चार quantity होते हैं. Okay, one is the PQV delta. So thereby what is the thing is, in this entire power system analysis, these 4 are been the common specified things. Out of these 4, 2 will be asked, 2 will be calculated. So here what is being given is active power and voltage has been given. The necessary conditions for power flow means what is happening is you need to make the calculation of the reactive power and as well as the voltage. See, in this session what is happening is, for the explanation of this one I am taking the more time, but what is happening is in the examination hall what is happening is you need not think this much of the lengthy thing, okay, immediately instantaneously you have to get the solution. So likewise what is happening is, here your objective is to calculate the Q and as well as the P value. So Q is equals to, we know the mathematical formula, that is equal to del V into V by X. Thereby here that is equals to, del V means difference of voltage, that is 66 minus 60 divided by root 3 into V is equals to 60 divided by root 3 divided by X is equal to how much? It is the 40. So you may ask me one question, why you have divided with the root 3? Because the thing is that what is happening there is, okay, so voltage and current, active power, reactive power existing for the 3 phase, voltage and currents are existing for line to line, okay, and phase to line, phase to ground values, but the impedance is always a per phase value only. So that is the reason what is happening is, in any mathematical formulation, if any network parameter is being there, with that network parameter what is happening is you have to refer all the quantities into per phase. So that is the reason what is happening is I turn this voltages into per phase. This is coming as what it is, 3 MVAR per phase. Okay, actually the calculations in by default are the 3 phase, no. So what we can write here is, for 3 phase, what we can say, this equals to 3 into 3, that equals to 9 MVAR. 9 MVAR is the concept that what you can have is, okay, this is the value, final value that what you can have is. Next, what is the other thing that you can go here is, so one you calculated, that is the thing is, that one is, this is determined. What is this value is being determined? This equals to 9 is determined. Next thing is, that one is you need to calculate what is the delta. Power flow condition P, Q, V delta, no, P is given, V is given, you need to calculate the Q and delta. So therefore what is happening is, one delta you have calculated, one Q you have calculated, other thing is you need to calculate is the delta. So let us go for this one is how you can make this calculation. So we know one thing is that the mathematical formula P is equals to EV by X into sine delta. So from this one is, delta is equals to sine inverse of XP by EV, okay, this one is, so that is equals to sine inverse of X is equal to how much? 40, P is 10 megawatts, that for the 3 phase. So therefore what is happening is, the per phase kitna hota hai? 10 by 3. So that is equals to 10 by 3 into, this is divided by, this you can expand like this, 66 by root 3 and 60 by root 3. This is equals to 5.79 degrees. Okay, this is the value that you can use. Mind one thing I am saying, that one is that this delta can have a limitation, that is delta should be around 5 degrees, under no circumstances it should exceed 10 degrees for a single generator. Some people who are watching, okay, this live attended my classes may be betterly known, that one is, for some people who have not attended, so for them, okay, as a notice points I am giving, that one is, you keep another ink, okay, with that what is happening is you can note this point, okay. So delta fundamentally it is around 5 degrees for a single generator. If it is, it should not exceed 10 degrees for a single generator. That is the way that you have to operate this one is, okay. So this is the concern that what you can have is, okay, this is the first question that what you can have is with the solution like this, okay. It is a very, very important question, basic power flow conditions, okay. Under the satisfactory of these conditions only what is happening, the transition of the power will be taking place. For the transition of the reactive power, there must be a potential difference. For the transition of the active power, the sending end should have the phase advancement over the receiving end. This is the thing is. Let's move on to the second question. What the thing is, A single phase transformer of 5 kVA 200 volts has an equivalent impedance of 2 ohms referred to the LV side. Express this impedance as a per unit referred to both LV and HV sides by taking the rated values as the base values. Okay, it is also a beautiful question. So this is belongs to the per unit system. Okay, this belongs to the per unit system. As for the per unit, why the per unit is needed here is, see, in power system we can have the different components with the different ratings placed at the different locations. So therefore, what is happening is for the common operating calculations, what is happening is one component should not be directly connected with operated with the other one. So that is the reason. Okay, what you have to do here is you have to refer all the things into per phase. So thereby you have to make them I have to refer in all impedances into a common base. That is being just like a uniformity. Okay, say कुछ colleges schools में देखते हैं आप लोग बच्चे लोग क्या है कि uniform पहन कर जाते हैं. Likewise, what's happening is to bring the common mode analysis, to bring the common mode platform for all the things. What is happening is you have to turn into per unit. That is the objectiveness of the per unit system. So how do you let this question here is, okay, so both the LV and HV sides. So first of all, let me go for the LV side. Okay, if I go for the LV side, so what it is said that under is taking the rated values as the base values. Okay, so what is the thing I can go here is MVA B base equals to 5 into 10 power minus 3. Reason is that one is it is given the 5 kVA. Okay, kV base, that is equals to how much it is? LV side how much? 200. That is 200 into 10 power minus 3. And ZLV, LV side Z is equals to is given as a 2 ohms. Then Z per unit is equals to what I can say, Z into MVA B divided by kV base square. It is a standard formula to convert into per unit. This is the formula, mathematical formula for the conversion into per unit. So as per that, you can say that one is Z is already known to you, that is equals to 2 into MVAB is equals to how much it is? 5 into 10 power minus 3 divided by kVb square is equal to 200 into 10 power minus 3, that is equals to 0.2 whole square. So this is amounting as 0.25. This is the per unit. That means that one is a 2 ohms impedance as a per unit can be represented as a 0.25. This is LV side. If I go for the B is HV side, if I go for the HV side, you can observe this one is same. I can say MVA B, that is equals to 5 into 10 power minus 3 and KVB, that is equals to how much it is? 400 into 10 power minus 3 and ZHV. Okay, this impedance of the 2 ohms is being given to the refer to the LV side only. Okay, so we need to make the calculation into the HV side. So if you make the calculation of the HV side, what it is being ZLV into HV by LV whole square. So that is equals to 2.0 into 400 divided by 200 whole square. So how much it is coming as? It is coming as 8 ohms. As it is coming as the 8 ohms, therefore on this side Z per unit is equals to 8 into, okay, 8 into how much? 5 into 10 to the power of minus 3 divided by 0.4 square. Okay, this also coming as a 0.25. If you make a simplification, you can get the 0.25. So through this question, what you have learned? You have learned one thing is that one is the impedance of the transformer referred to the LV side, HV side, both are being the same as a per unit representation. But if you see one thing is that one is impedance referred to the LV side as a ohmic value is equal to 2, okay, on the HV side as a ohmic value is 8. So that is the reason what is happening is whenever you are writing in a common base, whether to replace with the 2 or 8 is that some kind of a confusion or dilemma is being there. So that is the reason if you make into the translate the thing into per unit, whether you consider the primary side, you consider secondary side or LV side or HV side, the value of the 0.25 will remain same. This is the advantage of the per unit system. One important thing that you have to notice is that one is the impedance in the transformer refer to the LV side or HV side represented as a per unit will be the same. There is no differentiation. Clear? Next, the PU value of an impedance 0.8 on the base of 300 kVA 11 kV. What is the ohmic value of the impedance? In the previous question you have seen one thing is that raise, okay, Z per unit is equal to Z actual into what it is MVA divided by what I can say KVB square. So in this question what it is being given here is they have given the this thing is they have given the per unit value has been given and they are asking the ohmic value, just a reversal of the question. So Z per unit is equals to 0.8, question asked is equal to Z, MVA means what is happening is here it is a KVE, it is given in KVA. So therefore what is happening is it to be taken as a 0.3 divided by what it is a KVB square. KVB square is equal to how much it is being the 11 square. So from this you can solve Z as the value of 322.67 ohms. This is the ohmic value. Does this ohmic value changes if the bases are changed to 500 kVA 33 MVA? No. Okay, if the base value changes, ohmic value does not changes. If the base value changes, per unit value changes. The impedance is what? What is an impedance? I told you one thing is the tonnage, please repeatedly I am saying the same thing is keep the pen and paper with you. It is not the tonnage and the salient points where are being coming up you please note down. So that what is happening is it can flourish and it will be with you forever. So what I am saying in this case is what is the impedance? Impedance is nothing but an electrical mass. See, physically every component can be represented with its mass. Likewise what is happening is okay, physical representation or mechanical representation of any fundamental system is okay, any system's fundamental representation is by mechanical mode or physical mode which is being given in the weight. So likewise what is happening is electrical component is being replaced with an impedance means definitely I can say one thing is that one is impedance is nothing but an electrical mass. See, ये बातें क्लासेस में ना तो बात ये है कि किसी किताब में नहीं लिखा है, लेकिन हर बातें नहीं लिखा करती है, कुछ दिल और दिमाग से भी समझना पड़ता है. ऐसी पॉइंट पर मैं बता रहा हूँ आप लोग को impedance is an electrical mass. Okay, mass can be improved by improving the physical standards only. With the operational quantities the mass will not changes. So if the impedance to be increased, the impedance to be changed, physical dimensions to be changed. So the operating quantities if you are changing, impedance does not changes. Okay, the answer question for this one here is no, impedance does not changes. And what will be the new per unit value? You are having another mathematical formula that is ZPU2 equal to ZPU1 into MVA B2 divided by what it is MVA B1 into what it is KV B1 divided by KV B2 whole square. This is the translation formula that you can have is. And one more thing I am saying that one is through this class what is the formulas are being coming up for the solution of the various things. Okay, you have to underline them, you have to highlight them. These are the formulas are being very much useful. After the completion of the class, at the last I will tell you certain salient points. Okay, so watch this live properly and totally so that what is happening is it will give the maximum to maximum benefit for you, right. So accordingly this one is equals to 0.8 into this is equals to MVA B2 is equals to how much it is 500 divided by how much it is being the 300 into 11 by 33 whole square. So this comes as the value of 0.148. This is the value. So if you change the bases, the per unit value changes, but ohmic value does not changes. Ohmic value does not changes. Okay. So 0.148 with the 0.148 500 kVA and 33 kV. If you make a calculation, okay, what is the per unit value? Definitely you will get 322.67 you will get it. Okay. Move to the next question. Next what is happening is you can go for the transmission and distribution. Right. In this transmission distribution, the coverage is the transmission line parameters, performance lives, okay, and transient phenomenon and distribution. These are the coverage parts that what you can have. Say, and tell you one thing is that it is only the pure mathematical question session, but what's happening is I devised in these slides. The reason is that you should know the content properly. So why? Because I have not given in the serial number of 1, 2, 3 and 4 like that. Okay, but topic wise I have given the questions. Reason is that in every topic certain data type is being there. By making use of the data type, what kind of the questions can be framed and what kind of logical consigns that you could be able to make. Okay, so that is very user friendly to you. That is very convenient to you. So that is the reason what's happening is I made the thing in this direction. So the coverage in this is transmission line parameters, performance of lines, transient phenomenon, distribution. Actually, in the classification, I told you that one is after the basics, the first generation has to come. Since it is being the live concern for the gate examination, the generation and economic experts are being the least important for the gate examination. Okay, so they can have their own vicinity importance, assumed importance in the this thing is ESC examination, but gate it is a very less probability, even less than 1%. So that is the reason what is happening here. I spared it. Now we will move on to the questions. Okay, so first let us go for the transmission parameters. Based on this one, I will go for the questions. Okay, so first is that one is find the ds of a conductor having the 3 strands as shown in figure. Radius of each strand is a r. Say, what is the concern of this one? The concern of this one here is due to skin effect, total cross section of the conductor is not been useful. Mind one thing I am saying, that one is due to the effect of skin effect, total cross section of the conductor is not been useful, especially for the AC supply due to skin effect. Now you can see that one is, then I can assess one thing is that one is in this certain cross section is only useful, remaining cross section is not been useful. So because in skin effect what is happening is, what is the, how can you define the skin effect? The tendency of an alternating current is to concentrate on the surface layers. Okay? So therefore what is happening is, okay, the current crossing through the conductor is located on the surface section only. So as per that what is happening is certain major internal portion is not useful in this here and here and here also. So which portion is only useful? The portion which is useful is only this much only. This is the this hashed portion is the metallic portion through which the charges are crossing is only useful. This hashed portion. Everyone I am saying that one is you keep your mindset like this regarding this one race. Now the thing is that what is happening is all these metallic portion here through which the charges are crossing here and here. If you unite them, मतलब बात यह है कि यहाँ जिस portion में जिस दिस वन इज कंडक्टर पोर्शन में ये जा रही है, करंट जा रही है, जिसमें कहाँ जा रही है, इसमें कहाँ जा रही है, ये सब आपने एक जगह इकट्ठा किया है तो एक सॉलिड क्रॉस सेक्शन आएगा. So that solid cross section is this much. Let us consider. मतलब जो metallic portion through which the charges are crossing, through which the charges are crossing, through which the charges are crossing. If you have united, you have concentrated one location, that is equal to that cross section. Okay, so that is equal to this cross section. This cross section radii can be taken as ds. That cross section radii can be taken as the ds. Now, what is the thing he is saying that one is this is the ds that what you can have is. So we need to calculate this ds. So let us go back to our original color. So in this case, ds is equal to cube root of what I can say, cube root of some kind of some errors are been coming up. See, please cope up with this one race. Okay, so what I can say, it is equal to ds1, ds2 and ds3. Okay, so this one is. Now what is the ds1? ds1 equal to cube root of what I can say, this equals to d11, d12, d13. Okay, so cube root of d11 is equals to what? It is r dash. Okay, daa. So that is equals to how much it is? 0.7788 r into d12 is equals to 2r into d13 is equals to 4r. So this is equals to 1.84 r, and ds2 is equals to cube root of what it is, d21, d22, d23. This equals to cube root of d21 is equals to how much, 2r, and this equals to 0.7788 r, and this equals to 2r. So this equals to 1.46 r. ठीक है, ds2 is equal to, and as per this one is, you can say ds3 is equals to ds1, that equal to 1.84 r. So thereby what is happening is, here final thing ds is equals to cube root of what it is, 1.84 r into 1.46 r into what it is, 1.84 r. So this comes as the value of 1.703 r. ठीक है. So because we know one thing is the tonnage, as we know the tonnage, here you will be having this tonnage, here you will be having, here you will be having. Suppose if it is the radius, from this point to this point, if you take the radius will become as how much it is, 3r would be the radius. Okay na, but it is a physical form. But what is happening is, we know one thing is the tonnage, in each cross section total metallic portion is not been useful because of the skin effect. The useful metallic portion at the surfaces, if you unite, that effective, that is called the effective radius, effective conductor. Okay, that effective conductor's radii can be taken as the effective radius. That effective radius can be taken as the ds. The ds value is equals to this much in this case. Okay, so this one is, this is a standard question. All these questions are being the very standard. Means that one is, if you enter into the tonnage, suppose if you are playing the chess, you should know, okay, the functionality of each pawn. Okay, likewise what is happening is, likewise you are doing all these things. Okay. Next question is, a single phase system is constructed by spacing of 1 meter. The radii of each conductor is equal to 1 centimeter. Find the inductance per conductor if the conductor is made of copper and steel. Given the permeability of steel is equal to 100, if the copper is equals to 1. Beautiful question it is being. Okay, it is also beautiful question. Thing is that what is happening here is, the inductance L can be estimated as 2 into 10 to the power of minus 7 of what it is, mu r by 4 plus ln d by r henries per meter. Okay, this is the thing has been given. We know one thing is that, we know one thing is that every textbook has been given the formula in a different way. What is that one is, 2 into 10 to the power minus 7, 1 by 4 plus ln d by r. This has been given. Every textbook has been given. Okay, the thing like this. The inductance formula, the mathematical formula for the inductance has been given like was only. So that means that one is, okay, by making use of that formula, if you want to do this question, you cannot do. The reason is that what is happening is, you cannot make the distinction between the material of the copper and as well as the steel. Copper is a diamagnetic material. So therefore what is happening is, it is having the less permeability, high conductivity, okay, negative susceptibility, and the steel is the ferromagnetic material. It is having the high permeability. As it is having the high permeability, definitely what is happening is, it has to possess more amount of inductance. What is the permeability? Permeability is the ability to link up the flux. If the flux linkages gets increased, inductance should increase. So therefore what is happening is, if you make use of that formula what is been given in the standard literature, you can have the same value. But what is happening is, it should not be there. So thereby what is happening is, you have a different and you have the fundamental formula. That is the reason what is happening is, in the classes also, while I am deriving this question, the equation, I told to the students, the reason is that one is, in most of the textbooks has been given, they have taken the B equal to mu naught H. You have to take B equal to mu H as a Maxwell equation. If you take that one is, then what is happening is, definitely you are arriving this equation. So everything is fine. Here the thing is being given, that one is, here spacing means D is given as a 1 meter, okay, and R is given as what it is being the 1 centimeter. So first bit is that one is a copper. For copper, what it is given, mu R equal to 1. Okay, so therefore what is happening is, LC is equals to what I can say, 2 into 10 to the power of minus 7. Okay, mu R is equals to 1 by 4 plus ln D equal to 1 meter. That means this is equals to 100 divided by R is equals to how much it is being the 1. Okay. So this is amounting as 0.97 microhenries per meter. Okay. Now if you go for the B is for steel. Okay, for steel it is given that mu r is equals to 100, then L is equals to 2 into 10 to the power of minus 7, 100 by 4 plus ln 100 by 1. Okay, so this equals to, this is amounting as 5.92. Say after completion of the every question I am giving the conclusions, certain conclusions I am giving. By that time what is happening is, by observing that solution you need to write certain kind of the salient points, then only what is happening is things will flourish in a better manner, otherwise चीज़ें अधूरा रह जाते हैं। बाद में बात है कि स्टूडेंट्स के एक कॉमन नोट होते हैं, समझ में नहीं आया, समझ में क्यों नहीं आती है, समझ में नहीं आएगा अपने आप कोई भी चीज़ समझने के लिए कोशिश तो करना पड़ेगा। ओके, उसी दौरान मैं ये बोल रहा हूँ आप लोगों को ध्यान से सुना करो। जब ये क्वेश्चन आया था एग्जामिनेशन में, ओके, जैसा कि स्टूडेंट्स ने ये लिया था ना फॉर्मूला 2 × 10⁻⁷ 1/4 प्लस ln d/r, तो उन्होंने क्या किया था, कॉपर के लिए कैलकुलेट किया था, जो आंसर आया था उसको 100 से मल्टीप्लाई करके स्टील को डाल दिया था, गलत है वो। ठीक है, अगर इसको 100 से डाल दे तो मल्टीप्लाई करो 97 माइक्रोहेनरीज पर मीटर आएगा, लेकिन यहाँ आया कितना 5.92। सो देयरफॉर व्हाट इज हैपनिंग इज स्टील का इंडक्टेंस ज़्यादा का मतलब, इंडक्टेंस ज़्यादा का मतलब क्या होता है, मोर ओपन सर्किट हो जाता है। सो दैट इज द रीजन व्हाट इज हैपनिंग इज इट इज नॉट बीन एक्सेप्टेबल। ओके, सो दैट इज द रीजन व्हाट आई वांट टू लेट यू in this concern here is you have to make use of this formula. This is a very important note, okay, regarding this one is to explain this thing is, okay, this distinction in this calculation I took this question. Okay, next you see the figure shows the single phase double circuit line. L1 represents the inductance of the phase conductor, L2 represents the inductance of the neutral conductor. What is true? 4 options has been given. This is a beautiful question. Okay, so if you want to do conventionally this question, okay, it takes so much time, okay, so much time means what's happening is a minimum 15 minutes it will take to solve it in the conventional mode. But what's happening is with a simple shortcut I can give. See, in the classes I used to say one thing is that any question can be given for any number of marks. This question, same the question, if it is given for the 15 to 20 marks or at least for 10 marks this question will be given. Okay, so आप लोग को करने का तरीका अलग होता है। अभी तो बात यह है कि इस ऐसा ही दिया था ना, अभी तो बात है कि अपना सोचपन अलग तरीक़े से होना चाहिए। ओके, किस तरह होना चाहिए कि आप लोग देख लो। सो ये बोला है कि इंडक्टेंस, ओके, मतलब ये ग्रुप है ना, इसका इंडक्टेंस क्या बोला था, L1 बोला था, इसका ग्रुप का इंडक्टेंस क्या बोला था, L2 बोला था। सो विच इज ट्रू बोल रहा था। ओके, विच वन इज द ट्रू, देयर आर द 4 लॉजिकल कंसेंसस बीन गिवन. First thing is that what's happening is here, whenever the questions to be given in a conceptual solution, mind one thing I am saying that in a gate examination you will be having the 4 questions. As you are having the 4 questions, no, you are having the 4 questions, 4 options you are having is, in the 4 options what is happening is, mind I am saying that one is, it is a very important point I am letting you, because sometimes I too worked in question paper setting and all. So that is the reason while I am studying in my this one is IIT, so there what is happening is the teachers are often asking us to prepare the questions. So by the time they instructed me in such a way that is, out of the 4, 2 are worst, 2 are correct. 2 are worst, 2 are correct. First your expertise has to identify which are the wrong ones, remove them. Next 2 are the correct ones is there. One is 60% correct, one is 80% correct. Which one is the 80% correct, that you have to observe. So in this what is happening is, the configuration is the unsymmetric configuration. Definitely the phase conductor, inductance of the phase conductor is not equal to the inductance of the neutral conductor. So first wrong choice is L1 equal to L2. Okay, actually here is not that one is, it is approximately equal. So in L1 equal to L2, the 2 choices will not be there. Some typo error is there. That is the reason L1 equal to L2 is not correct. L1 approximately equal to L2. Actually, logical comparison we can do for 3 comparisons only, but we have to give the fourth option. The most useless option, fourth one, sometimes is added like this. Thereby what I can say, this is also wrong option. So either the B or C is the right options. So how to select this one is, let me consider all these phase conductors are carrying the currents of I, I, I. Put together kitna hua tha? 3I. The 3I current should be written from from where? From neutral. Okay, 3I current has to be written from the 3I current has to be written from the two conductors means what is this one is 1.5I, 1.5I. So now you tell me that one is which conductor is carrying the more conductor, phase or neutral? Neutral. If the current carrying through the conductor is being the more flux linkages is there. More flux linkages is there, then what will happen? More inductance. Okay, so thereby what I can say? Definitely I can say L2 is greater than L1. कहाँ है वो? अच्छा ऐसा नहीं दिया था, तो इसको कैसे ट्रांसफॉर्म करेंगे? L1 is less than L2. Okay. See, thing is that what's happening is you can have the two things. इसको क्या बोलते हैं कि here you can say one thing is that what's happening is here the inductance depends upon. Okay, see, as per the formula we are having the formula like this: L is equals to 2 pi 2 into 10 to the power of minus 7 ln d by r dash may be the formula that you can have is. As per this, somebody is saying that the inductance depends upon the distance. Definitely I am saying that inductance depends upon the distance, but what is happening is before this equality one more equality is there, that is equal to psi by I. So this formula is made true when the current is of the rated value. The moment when the current changes, definitely that formula gets changes. So that is the reason what is happening is the prime concern for the inductance value is the current, next is the distance. When the rated current is being there, then the distance it is there. So distance is the physical one, okay, current is the electrical one. Therefore inductance, the flux linkage depends upon the current only. So that is the reason what is happening is your first, suppose let us say one thing is that okay inductance depends upon A, B, C, D or 4 options are there. In the 4 options you can have the 2 options. One option is the distance, another option is the current. Which one you will select first? Current is the first, distance is the second. If the current is not there, distance is the right answer. Okay, to illustrate that point I have taken this question. Okay, unsymmetric configuration it is. So you make it by taking the radius r is equals to 1 centimeter. You make a calculation. Okay, you make that means that one is here inductance क्या होता है? L1 is equals to 2 into 10 to the power of minus 7 ln what it is dm1 by ds1, and L2 is equals to 2 into 10 to the power of minus 7 ln dm2 by ds2 by the procedural concern of the dm1, dm2 and ds1, ds2. And one more thing here you need to consider is, by I can declare one thing, dm1 equal to dm2. Reason is that one is dm is the distance, effective distance has been taken between the conductors which are having the go and return polarity. So that is the reason what is happening is I can say okay, 3 conductors are going, 2 are returning. If these 2 are acting as the go conductors, these 2 are acting as the return conductors. That means from here to here the 6 distances are there, from here to here the 6 distances are there. So that is the reason what is happening is dm1 equal to dm2. But ds is the consolidation for this one, consolidation for this one. So that is the reason what is happening is they are being the different ones. As they are being the different ones, then what I can say that one is you need to make the separate calculation for the ds1 and ds2. dm1 is being the common, dm1 equal to dm2. If you make the evaluation like this, definitely you will get the inductance of this phase conductor is found to be less than this neutral conductors. So that to determine, that to justify, it will take 10 minutes. Okay, 10 to 15 minutes it will take. But what is happening is by this phenomenal concern, I just explained in okay 10 seconds that is being. Okay, the 3 phase conductors are carrying the 3I currents. They are to be written from the 2 conductors means 1.5, 1.5. So if you take the phase and neutral, the phase conductor is carrying the less conductor than the neutral. As the neutral is carrying the more conductor, therefore it can have the more flux linkages. Therefore inductance will be more. So that is the conceptualization. Okay, the two conductors spaced of 1 meter of each radius 1 centimeter. A third conductor of the same radius is placed at the same distance from both of the conductors. Find the spacing of the third conductor if L2 is 5% more than L1, right. So, first of all you calculate the L1. L1 is equals to 2 into um, 2 into 10 to the power of minus 7 ln d by what it is being r dash. So, that is equals to 2 into 10 to the power of minus 7 ln d is given as a 1 meter. This is the thing. 1 meter means what is happening is, okay, radius normally having then centimeters, that is the reason you can take it 1 centimeter radius. 1 centimeter radius means what is happening is r dash is equal to 0.7788 r. So, that is equals to 0.7788 centimeters. Actually here what is happening is the space is limited. That is the reason what is happening is I need to organize the question. That is the reason what is happening is wherever the space is available I am writing. You please take care in that direction. Okay, r dash is this one is. Therefore, what is happening is it is 0.77 what it is 88. So, that is equals to how much it amounts? It is it is coming as 0.971 microhenries per meter. Okay. What it is given, that one is L2 equal to 1.05 into L1, that equal to 1.05 into 0.971. Okay, right. That is equal to 0.019 microhenries per meter. ठीक है, L2 equal to what fundamentally? L2 equal to 2 into 10 to the power of minus 7 ln cube root of. So क्या हुआ था पहले first case में, so there are two conductors are like this. Okay, these are the two conductors. Between them the distance is equals to 1 meter. This is equals to A and B, and the radii has been taken as how much it is being, it is equals to 1 centimeter. Here also it is been taken the 1 centimeter. Now in the second case क्या बोला था, so as it is, it was there, A is there and this is the conductor B is there. This is the A conductor and this is the B conductor. It is having the 1 meter distance, and what it is said that one is a third conductor is being placed here. Okay, a third conductor has been placed here. So the third conductor equal to C of what it is said, that one is, it is said that of same radius. Okay, 1 centimeter. So it is kept at the same distance from both A to B. So this is the D and this is the D. Okay, now what is happening is, I can say one thing is that without doing this, without putting pen and paper, you can solve this question. Without putting pen and paper, you can solve this question. See, one thing I am gone up to this point. There is stopped and continued in a conceptual mode. Say in the gate, what is happening is, you have to mind one thing, 60 to 70% questions are conceptual based. That means without putting pen and paper, by assessing the data type, by assessing the logical concern, you could be able to give the answer. Here also I can give the answer like that. How it is been here is, here what is happening is, these two conductors having the 1 meter of the distance, no, right. Third conductor is placed. By the placing of the third conductor, inductance per conductor is increased or decreased? I am saying that one is, by the placing of the third conductor, inductance per conductor is increased or decreased? Definitely increased. Okay, it rises to the 1.09, increased. So the increase in inductance is being possible by increasing the distance. Here the regarding the currents, nothing has been given, therefore we need to assume current is being the constant. So therefore what is happening is, when the current is being the constant, inductance increased means distance should definitely increase. So that means that what is happening is, you can see that one is, so distance should increase means it remains same, wrong answer. It is decreased, it is a wrong answer. There are the two things are there, 2 meter and 1.43 meter is being there. So there is a certain toggleness is being there, okay, to or mid. Increase means both are indicating the increase, but what is happening here is that much of the double the increment drastically may not be possible. So that is the reason this also can be wiped off. Therefore, this can be taken in the right answer. Okay, a little wise transition is there because the change is only 5%. The change is not vast to be there. If the change is much more, 20%, 30% higher change is being there, then what is happening is you can take the higher differentiation. Okay, so it is being the smaller change is being there. That is the reason what is happening here is 5%. Only 5% is changed. So slight change you can observe. So in that concern, I can say it is equals to 1.43. Okay. So this is the observation one should have. Now cube root of this equals to this distance that is equals to 100 and into d divided by here d divided by how much it is being r dash, that is equals to 0.7788. that is one is. That means how you can equate this one, 1.019 into 10 power minus 6 equals to 2 into 10 to the power of minus 7 ln cube root of what it is 100 into d square divided by 0.7788. From this you can take the d equal to 1.43 meters. This is the answer you can have. Okay. So once again I am letting you one thing is that one is this is the standard case. Now the introduction of the third conductor, with that inductance is increased. Inductance is increased, that is possibility is there by distance. Okay. So by changing the distance, what is happening is you could be changing the increase in distance, the inductance can increase. So that is the reason what is happening is same value and lesser value are considered to be wrong, and this thing is that what is happening here just 5% change is there. So in दोनों में कौन सी change there, increase is there, lesser increase 1.43, that you have to take it. So if you could be able to make the observatory or observation in this sense, then what is happening is you need not worry much more. Okay, with a simple thing that you could be able to get it. Conceptual approach is being the very important one. Okay. Next question, a 132 kV 50 the transmission line is a configured as shown in figure. Find the charging current for 10 kilometers. Okay, so the charging current IC is equals to V into omega C. So here what is happening here is 132 kV V has been given, frequency is also omega is the V 2 pi f. Okay, the main idea here is to calculate the this one it is. Okay, oh, take it as here what is happening is radius is not been mentioned. Okay, radius of the conductor is equals to, you take it as a 1 centimeter. Okay, then C is equals to, what is the formula that you can have is 2 pi epsilon naught ln dm by r, because the thing is 3 conductors are there, no, dm by r. Here the what is the dm? Dm is equals to cube root of one conductor, other conductor is a 2 meters into 2.5 meters into 4.5. So if I label like this ABC, this you can write it as a okay DAB, DBC, DCA. So this is coming as 2.823. Okay, you can check out with your numerical calculations. Okay, कहीं पर भी अगर मेरा भी गलत हो सकता है. Okay, खराब ही क्या है कि मेरा भी थोड़ा गलत हो सकता है. So therefore what is happening is you can observe. ठीक है, you can observe that one is okay. Some students are giving the answers immediately. Okay, I am very happy that okay they are strictly following that one is Priya Tiwari. Okay, you have given the right answer in the previous case, right? So you to give the answers. Okay, so that what is happening is I can see that one is if any typo error, any grammatical errors are being there, you please specify also so that I can correct. Okay, so this is the thing is dm is equal to this one. Now the C is equals to 2 pi into epsilon is equal to what? 8.854 into 10 to the power of minus 12 divided by ln this equals to 282.3 divided by 1. Here what is happening is for the calculation of the capacitance you should not take the R dash. Reason is that what is happening is there is no GMR effect, there is skin effect is not been valid in case of the calculation of the capacitance. So that is the reason there is no R dash. Okay, you have to take only R only. Okay, you should not take the R dash. Reason is that what is happening is while you are confident, see, you can see one thing is that one is inductance formula while you are writing L equal to 2 into 10 to the power minus 1 mu r by 4 plus ln d by r, you have written the two patches. What for internal flux linkages, external flux linkages. Likewise, the capacitance while you are calculating, you have taken in only one patch. Reason is that what is happening is the potential inside the conductor equal to 0. The potential outside the conductor is only existing. So that is the reason what is happening is you can have only one. So the internal component of the potential is not to be considered or considerable. So that is the reason what you can say. There is no inside potential. Okay, the potential outside the conductor is only accountable. Okay, that is the reason what is happening here is when the inside configuration, conductor configuration you are not considering, because of that thing what is happening is there is no effect of GMR. So as for this, the capacitance C is equals to how much it is 9.85 into what it is 10 to the power of minus 12. Now the charging current IC is equals to V is given 132 divided by root 3. The charging current is going, the capacitance you have taken the line to ground, therefore what is happening is you need to consider the potential also line to ground. So therefore what is happening is 132 kV into 10 cube into what it is 2 pi into 50 into what it is 9.85 into 10 power minus 12. This is equals to 2.35 into 10 to the power of minus 4 amperes per meter. Okay, this is per meter. Okay, for 10 kilometers you need to calculate. For 10 km IC is equals to 2.35 into 10 to the power of minus 4 into 10 into 10 cube, because 10 kilometers का meters कितना होता है 10 into 10 cube. So that is equals to 2.35 amperes. Here I need to consider one thing is the turner is, okay, the charging current should not exceed the 4 amperes. Okay, there is a limitation is being there through the conductor. Charging current should not for the 4 amperes. If it is crossing the 4 amperes, it can develop the arcing grounds. Okay. So the arcing grounds is means that there is a conduct space between the conductor to the ground is gets ionized, and the space between the conductor to ground is ionized, then there is a discharge currents are being there. So therefore what is happening is to avoid these charging currents, the spacing, insulation coordination, everything has been designed in such a way that the charging current of the line should not exceed 4 amperes. Wherever you make the calculations of the charging currents, definitely I can say one thing is that one is the charging current definitely will be less than 4 amperes. It is a standard one. Okay, the system has been designed, spacing, conductor cross section, okay, potential, everything has been designed in such a way that one is the charging current should not exceed the 4 amperes. If it is exceeding the 4 amperes, definitely it will develop the arcing ground. Through that discharge will be there itself. Okay, so that is the reason. Just we go for the next topic of concern is the performance of lines. Okay, right. A 3-phase 60 km 66 kV 400 AC transmission line carries 15 megawatts. This line can be modeled as, right. We know one thing is that it is modeling of the line or classification of the line, categorization of the line. The categorization of the line, in the definition it is being done with 3 things: length, voltage, frequency. These are the 3 considerations are there. Okay, in this what is happening is the first priority you are giving for the frequency, second priority for the voltage, third priority for the length. Okay, there are 2 types of transmissions are there: power frequency transmission, carrier frequency transmission. the power frequency is in the range of 50 to 100 Hz. The carrier frequency is greater than 100 Hz. Okay, here you tell me one thing is that one is the operating frequency is how much it is 400. That means the what is happening is this is in the range of carrier frequency. The carrier frequency transmission is been possible in the long transmission lines only. What is the carrier frequency transmission? Means that what is only the conductor is there. Around this conductor certain ionized space is there. Through this ionized space a high frequency signal has been sent. The high frequency signal has been sent. What for purpose? Two purposes. One is for the communication, another is for the protection. Of course, today what is happening is so many vast communication modems has been came. So that is the reason what is happening is we are not considering the communication. Okay, we are just letting it for the protection only. So thereby what is the thing I can say? The protection, faster action protection, fast acting protection. Okay, so is possible with the high frequency transmission. So that is the purpose of this one is. Okay, so carrier frequency transmission always be possible in the long transmission lines. That is the reason for the moment the answer is the long transmission line is the correct. If you observe one thing is that one is if you see the length, according to the length it is the short transmission line, according to the operating voltage it is the medium transmission line, according to the frequency it is the long transmission line. Okay. So therefore what is happening is some people may argue this also right answer. Okay, this also right answer. But what is happening is okay, what are the thing is I can say one thing is that is so it is some people are arguing, some people will say that all the things have been satisfying. That is the reason what is happening is all the above. No, it is not the all the above, it is the long transmission line only, because thing is that according to the length you can observe it is the short transmission line, as per the voltage it is the medium transmission line, as per the frequency it is the long transmission line. So all the three possibilities are being there, then what is happening is you have to go through the priority basis. According to that one, the first priority is the frequency. So according to that what is happening is it is matching the carrier frequency, therefore it is the long transmission line. Okay, instead of giving the 400 Hz, suppose let me say it is given as the 75 Hz. Instead of giving the 400 Hz, it may given as the 75 Hz. Then what I can say? What I can say, it is a power frequency transmission. Power frequency transmission is being possible for all the three lines. Okay, na? So therefore, what is happening is I random boldly I cannot take my choice of long transmission line. Okay, so therefore, according to the frequency, all the lines can have the same categorization. Now I will go for the second priority as the voltage. According to the second priority of the voltage, this range of voltage, that is how much, 20 kV to 100 kV are in the medium range. So therefore, what is happening is this line can be taken as the medium transmission line. So we have made the classification in that direction itself. Okay, so length up to 80 kilometers, up to 20 kV, power frequency is the short transmission line. This one is a 80 kilometer to 160 kilometers, 20 kV to 100 kV, and power frequency transmission can be taken as the medium transmission line, and more than 100. This one is more than 100 kV, and the length is 160 kilometers to 280 kilometers, and this one is a frequency, both power frequency, carrier frequency, both can be done with a long transmission line. Likewise, what is happening is this question to answer, okay, very simplified. This much of the background, this much of the matter if you are having, you can answer immediately. Otherwise, what is happening is it takes much more time, and definitely you commit a wrong thing. So with this simple question, what is happening is all the classification of the lines that I have explained to you. Next is that single phase transmission line, the impedance of 8 plus j6, the power factor at a maximum regulation is, okay, right. So at maximum regulation, what is the condition? Phi equal to theta. Theta is equals to what I can say, tan inverse of x by r. So this is equals to tan inverse of x equal to how much, 6, and r equal to 8. So this is equals to how much it will be, this equals to how much it is, 36.86 degrees. 36.86 degrees. Okay, tan inverse this one is, okay, now Okay, now the power factor equal to, क्योंकि theta is equal to phi equal to theta, no? So therefore what is happening is, therefore here phi equal to theta, and you can say that one is phi is equals to 36.86 degrees. Then what is the thing I can say, that power factor equal to cos 36.86 degrees. This equals to 0.8. What it is 0.8? Lead or lag? This is the thing is, okay, at maximum regulation the power factor will be lagging. Why? You are having the percentage regulation or differentiation. The percentage regulation, you can take it as like this. You have taken something like this. A drop you are taking, no? In the drop you can take the plus or minus. So in the formula of the drop you are taking the plus or minus. Okay, the regulation to be 0, the two components can be, okay, the regulation to be 0, the drop to be 0. The drop to be 0 means what is happening there is a component A and component B can have the negative sign. So that is the reason what is happening is a minus has been taken. Minus has been taken means that is the leading power factor. Okay, for the regulation to be maximum, क्या होना चाहिए? The drop to be maximum. Drop to be maximum is possible with plus sign only. Okay, with plus sign what it is being? It is a lagging. So that is the reason what is happening is by default at the maximum regulation it is a lagging. So therefore what is happening is the 0.8 lag is the right answer. A is the right answer. Okay, very good. Okay, some people are responding. Right, very good. So some good comments are being coming up. Okay, Kushbu Prajapati, and very good. Okay, so latest notes of sir, can you latest notes of power system, right? Okay, Himan should be okay. So very nice. Very nice to observe all of you. Okay, so thing is that what is happening is you can go through this one is okay. So this is the point that what you can have is just simple question. Next is that one is the transmission parameters of line is equals to A equal to D equal to 0. For the regulation, if the sending end voltage is 210, receiving end voltage equal to 220. So we know one thing is that one is a percentage regulation is equal to V dash minus VR divided by VR into 100. So V dash is equals to how much? Vs by A. So that is equals to 230 divided by A equal to 0.96. So how much it is? This is equals to 239.58. Okay, so therefore percentage regulation is equals to 239.58 minus 220 divided by what it is 220 into 100. So this is equals to 8.9 percentage. Okay, so this is the concern that what you can have is normally what is happening there is ये ही बोल रहा हूँ आप लोगों को ये आंसर भी आप बिना कुछ कैलकुलेट करके बता सकते हैं कैसे normally what is happening there is it is for the transmission the regulation is should be around 5%, for the distribution what is happening is around 6%. कभी भी maximum to maximum what is happening is 5% से ज़्यादा होता है कभी भी very rare cases में less होते हैं. So that is the reason what is happening there is I need not consider this answer. And one more thing is that one is mind one thing I am saying that one is the insulation coordination for every system can be designed as for 10%. That is the reason that is okay 100% rise of the current is acceptable, but 10% rise of the voltage is being so dangerous. So that is the reason maximum insulation coordination okay is designed for every system as a 10%. So that is the reason the regulation limitations are there as a 5%, 6%, but under no circumstances regulation should exceed 10%. So thereby what is happening there is this is the wrong answer, this is also a wrong answer. So this is the right answer. Likewise certain shortcut tips are there. So in this class what is the thing is conventionally you can do along with me, but what is happening is the moment when I am speaking something that you have to make note of that thing is okay, very important thing is okay. These are the beautiful questions that what you can have is we have designed all these things. Okay, next is that one is in a transmission line of theta equal to phi equal to 45 degrees the nature of the load is very good. Here what is the point is that here this question is an excellent question. You please listen here itself is the concept based, very much concept based. Can anybody give the answer for this question? I will wait for a few minutes. Anybody, please post the answer. Himanshubi, Aniket, Himanshubi, what you have given the answer is RL. Right answer. This is the right answer. Correct. How it is being here is, you can see one thing is that one is here the two things are there. One is that one is regulation maximum at where it is been happened, theta equal to 5. Second thing is that regulation is 0 where it is possible, theta plus 5 equal to 90 degrees. In this case, power factor is lagging. In this case, power factor is leading. If you observe, the thing is for this condition both are satisfying. Both are satisfying means what is happening is it is lead or lag. One particular thing, lead or lag, you can't speak it out. Okay, na? So that is the reason what is happening is we have to toggle what it is the right answer. Definitely it is being one thing I am saying that is, okay, some angle is existing means it is not the R. If R is there, that would be equal to 0. And it is not all the C also. If the pure C is there, it would be 90 degrees. Then what is happening is the theta is equals to 45 degrees means it may be either the combination of RL or RC. It should not be the pure R or pure C. So मैंने आपको लगातार एक चीज बोल रहा हूँ. The questions I have designed in the same way itself. Okay, what are the thing is out of the 4, 2 are the correct, 2 are the worst. These 2 are the wrong answers. Therefore, what is happening is in these 2 you have to toggle. Okay, so these two in this question, for this question both the conditions have been satisfied. Both the conditions have been satisfied means definitely what to be happen, it is it should be either lead or lag. Okay, that is not the right thing is, you have to specify either lead or lag. Okay, you see one thing is that these two become, there are many possibilities are there. Theta plus phi equal to 90 degrees to become much more probabilities are there. Infinitely many probabilities are there, but theta is equal to phi is only one probability. So as per the priority concern, this is to be taken to be consideration. If this is taken to the consideration, the power factor is lagging. So with the capacitance, the power factor will lead. With the inductance, only the power factor is lag. Therefore, this is the right answer. I hope you understand the concept. Okay, through concept only you have to get the solution for this question. Okay, so this toggleness, this to be very much importantly you have to keep in your mind, because the thing is at this, see, if theta at other combinations of the theta and phi both are not being satisfied, at this only what is happening is both are getting satisfied. So that is the reason what is happening is okay, we have to in a probabilistic way you have to give the answer. Next is that one is in a medium transmission line, the current at the receiving end is equals to 200 amperes. So the power factor 0.8 lag. What is the current at the sending end? Right. So you are having one formula. What that is, sending end current is equals to receiving end current plus charging current. Receiving end current IR is equals to what it is been given, 200 of 0.8 minus j 0.6. Lagging bola tha na. So therefore you need to consider like this. So if you take into the components, this is equals to 160 minus j, what it is being, that one it is 120. Okay, this is the components that we can have is right. So this one is the receiving end current. To this one is we need to add the charging current. अभी मैंने आप लोगों को बोला था चार्जिंग करंट डेफिनेटली ओके शुड नॉट एक्सीड द 4 एम्पियर्स. ओके, ठीक है, टेक द मैक्सिमम इज एज अ 5 एम्पियर्स J5. This is just I am taking for the sake of explanation only. So then if you add up these two things, IS is equals to IS is equals to what you can say, this one is 160 minus j 120 plus j5. So this is equals to 160 minus j 115. That means this combination definitely less than the magnitude of IR. Here the thing is that what is happening is all the 4 has been given, no. So one thing is that one is a medium transmission line. In that what's happening is the sending and receiving end are there. In between the capacitance is there. Some drop of the current is being there. In the short transmission line only IS is equal to IR. In the medium transmission line IS is not equal to IR. So this is the wrong answer. And one more thing is that one is for the current at one side is the 200, other side is 400 means doubling of the current is being possible at under fault conditions only. Okay, under fault conditions only doubling of the current is being possible. So that is the reason what is happening here is the answer 400 is also wrong answer. Okay, so one is 195, another is a 205. That what it indicates that one is more than the 200, one is less than the 200. That means that one is the answer is more than 200 or less than 200 is the concern that what you have to have. Okay. Okay, so what is the thing that you can say is, okay, you can say one thing is that one is more than 200, one is less than 200. That is the concern that what you can have is, okay, so if you take this combination, it will come as less than 200, and less than 200 means this is the right answer. Okay, actually here what I want to tell you that one is, so sending end current IS, okay, to be obtained, what is the formula that you can have is CVR plus DIR. देखो इस क्वेश्चन को किस तरह सॉल्व करनी है मैं बता देता हूँ. IS is equal to CVR plus DIR. This is the mathematical formula that you can have is, okay. In this formula, that means that IS to calculate, you require the four things you have to know. What are the four things? One is the C, another is the D, another is the VR, another is the IR. Four things you should know. But what is being given? Only one IR has been given. Remaining things is not being given. Neither B, C is given, D is given or VR is given. In this case what is happening is, how can you make the calculation? That means with this data type conventional solution is not being possible. As a conventional solution is not being possible, you need to go to the conceptual solution. What the conceptual solution is saying that is, here it is the power factor is lagging in nature, no. So that means it can have the magnetizing component. Some magnetizing component has been compensated with the capacitive component of the line. So that is the reason what is happening is, the moment when you are coming into the sending end, then what is happening is that magnetizing component is coming from where? That is coming from the load itself is gets compensated. So that is the reason what is happening is, the reactive component is the magnetizing component is being the lesser, because some magnetizing component is being compensated by the line capacitance. So that is the reason sending end current is found to be less than the receiving end current for lagging power factors. Suppose if it is given that one is the power factor is, instead of lagging, if it is being given as the lead, then what it will be? If it is the leading power factor, you can say this will become plus, this will become plus. Then as this is becoming plus, as this is becoming plus, this is equals to 125 हो जाता है. Then what is happening is current is more. So therefore what is happening is this is the right answer then. So mind one thing I am saying that one is, it is the conceptual concern that what I can say is, listen carefully, I am saying that here you can say that one is here the current is the receiving end current and this is the sending end current. I can say IS greater than IR for the power factor of leading, IS less than IR for the power factor of lagging. Okay, so मैं ये बोल रहा हूँ, बात है कि conceptually you can do, okay, see, think it the transition conventionally you can do, but what's happening is the conceptual evaluation is the best thing is. Suppose tomorrow you are going for the ESC examination where you have to make the conventional solutions, okay. So before leaving the question, going into the next point, okay, next thing, you are going to the next topic, okay, you check that one is whether the question is conventionally, conceptually correct or not. Suppose something is that one is in the examination you can have a tension, okay, so उसकी वजह से बात है कि सिर पर बात है कि बहुत सारा बोझ लगती है कि कब ख़त्म करें जैसा करें, तो उस टाइम में बात है कि कहीं ना कहीं गलत कमिट करने के लिए कोई चांसेस होते हैं. इसलिए मैं ये बोल रहा हूँ बात है कि बिफोर यू आर गोइंग फॉर द नेक्स्ट क्वेश्चन, ओके, क्रॉस चेक द थिंग इज इन ए कन्वेंशनल मैनर, कॉन्सेप्चुअल मैनर. कॉन्सेप्चुअल इफ इट इज ओके देन यू कैन गो टू द नेक्स्ट क्वेश्चन. ठीक है, दिस इज द थिंग इज नेक्स्ट. If the surge impedance of the line is 2500 megawatts, the line inductance is compensated by 17%, then what will be the new SLI? Okay, so surge impedance, okay, right. So we know one thing is that surge impedance loading is equals to V square by Zn. Okay, so then what is the thing that I can say is, you can have a formula that is SIL2 divided by SIL1, that equals to what I can say is Zn1 divided by Zn2. SIL1 is given as 2500, okay, and megawatts this is, and Zn1 equal to root over what I can say L by C. Zn2 क्या होता है? Zn2 is equals to root over 17% is a compensated है ना, so remaining is equals to 83%, 0.83 L by C, that equal to you can take as a 0.83 under root into what I can say Zn1. Thereby SIL2 is equals to SIL1 is equal to how much it is being, the 2500 into Zn1 divided by what it is root over 0.83 into Zn1. So Zn1 gets cancels. This remains as the 2750, something like that. As something 24 actual answer you will be getting in a different way. 24 something that you are getting, but what I want to say in this case here is 245 something will come, but it is the capacity, no, that to be adjusted to the nearby the round integer. So nearby tens you can have. So that is the reason this is the right answer that you can have. Simple mathematical calculation. इसमें ज़्यादा stress और strain नहीं है. Simply 2745 something will come, but it to be round up. Sometimes what's happening is the answer is exactly not being present there. It is the capacity, no, it is not coming in the fractions and decimals. So that is the reason what's happening is he will adjust near to the 10 or near to the 100 also sometimes. So instead of giving this in 2750, if the answer comes as the 2800 also, that is also correct. Again and again I am telling you that one is all these points you have to note down in a proper manner. Okay, so these are all the hints and tips that what you can have is, so that what is happening is numerically how to solve the things. Okay, so this is the concern that you can take. Next is that one is, in which modeling of the line regulation of the efficiency, regulation efficiency are the better? Nominal T, nominal pi, and condenser method same in both the modelings. Okay. Point is that what's happening is nominal T, nominal pi are the two configurations that you can have is. Let me consider what is the nominal T. Okay, this is half the resistance, half the inductance, and here the half the resistance, half the inductance. Okay, and what's happening is this is the modeling of a T. And what is the pi modeling? The resistance, reactance, okay, and here half the capacitance, here half the capacitance. This is the modeling that you can have is. Okay. Now we know one thing is that the current here is equals to IS, this current is equals to IR, this current is equals to what it is being IC, this current is equals to IS, and this is equals to IR, and this you can take it as a IC1, this you can take it as a IC2. So in the classification of the lines, some, okay, I told you one thing is that one is the discrimination between the lines is been coming up when with the influence of the capacitance only, with the influence of the capacitance only. Okay, so in the medium transmission line classification से पहले बार यही बोलते हैं, depending upon the location of the capacitance, these lines have been modeled in the three model methods: end condenser, nominal T, and nominal pi. These are the three modelings that we can have is. Okay, capacitance is the distinction. In the previous examples and previous questions, you have seen one thing is that one is, I told you one thing is ध्यान से सुनो, बहुत important concept है ये, बहुत important concept. Okay, I told you one thing is that the charging current is always less than 5 amperes. Charging current is always less than 4 amperes. That means that what is happening is, through the line hundreds of currents are going on. Through the shunt branching, if the 4 amperes current is been coming up means, okay, as the current flowing through these capacitances or the shunt branches is a very small when compared to the series current. Okay, so the current is coming in this shunt branches is found to be very less when compared to the current flowing in these lines. Okay, so therefore what I can say? I can neglect this part. I can neglect this part. If I remove this part, okay, suppose let me say one thing is that one is if I remove this part like this, okay, Um, if I remove this part here and this part here, then both the lines are same or not? Both the modeling will be the same or not? Both modeling will be the same means what I can say? What I can say? Efficiency and regulation in both the cases will be same. Got it? Efficiency and regulation in both the cases will be. क्या difference क्या है दोनों में अभी? इसको ऐसा ही कर सकते हैं, दोनों ये दोनों ऐड करके then what's happening is if you are eliminating that branching, shunt branching, then what's happening is both are being the same. As both are being the same, efficiency and regulation both are found to be same. Okay, so for the sake of regulation and efficiency, if you take the nominal T or nominal pi will give you the same. Okay, the people who have attended my classes, for them I have given one question also. Okay, with that question what is happening is I asked them as a homework I have given, I asked them to okay make this calculation. You take any data, any standard वादवार कोठारी जो भी किताबें आपको चाहिए वो लीजिए, आप लेकर उसमें आप कैलकुलेट कर दीजिए. ओके, आपको तो बात यह है कि आपको पता चल जाता है कि कोई भी डेटा तक ले लो, डेटा लेकर आप नॉमिनल पाई नॉमिनल टी बोथ दो कर लो. Okay, definitely you can have it. I cannot prove, I can do, but this it is not the conventional mode of class, no. So that is the reason I am telling you like this. Okay, so once again I am saying that one is for the sake of regulation and efficiency, nominal pi nominal t both are being the same. Both will give you the same efficiency and regulation. Some people has given that answer is the B, nominal t or nominal pi. Okay, definitely what's happening here is okay. Okay, so that is the reason what is happening here is it is not correct thing is okay, right. Next, okay, so for the transfer of the maximum power from source to the load, which condition to be satisfied? Okay, the thing is that what is happening is you can have the source and as well as the load. For the transfer of the maximum from source to the load, क्या होना चाहिए? So you can have a simplified conceptualization that I can take it. Okay, what is the thing I can take here is. Okay, simplified conceptualization I will take. What is the simplified conceptualization I can take is, let me consider it is the source, okay, alright, and it is the load. We know one thing is that one is from the we know one thing is that one source and the transmission system has been represented with R plus jx. Okay, now the thing is that what's happening here is this is the one is okay, so maximum power to be transferred, maximum power to be transferred. So you see one thing is that one is for the transfer of the maximum from source to the load impedance must be complex conjugate of the internal impedance or the source impedance. The internal impedance means what is happening is the impedance of this one and impedance of the transmission system totally modeled as R plus jx. The load impedance must be complex conjugate of this one. Complex conjugate का मतलब क्या होता है? So if it is R plus jx, it should be R minus jx. Plus jx here it is being with inductive in nature, then minus jx will be capacitive in nature. इसका मतलब है when the load is of capacitive in nature, then only what is happening is the transfer of the maximum power from source to the load is possible, and the load is of capacitive in nature, then only the transfer of the maximum power is being possible. Thereby, if I consider the load is of the capacitive in nature, the load will inject the reactive power into the network. Okay, so the thing is that for the transfer of the maximum power from source to the load must inject the reactive power into the network. Then only the maximum power transfer is being possible. Okay, so I'm letting you one thing is that one is power system does not have any simple patent. Power system is the combination of the so many things. So that is the reason what's happening is a knowledge of all network, machines, control, power electronics, measurements, even electronics. Okay, all are required. So thereby what I want to tell you in this concern here is you please be aware of all these things. Okay, at the stack memory बोलते हैं, top layer of the brain, all these to be presently be there. Then only what's happening is you can flourish, because the thing is that one is from one location to other location you have to jump. If you don't have that kind of the jumping, you cannot get the things. Okay, so that is the reason what I am saying is that one is here I have to, for the power system the answer for the power system question I referred from the network analysis. So that is the reason what is happening is you have to acknowledge the thing is like this. Okay. So complex conjugate means what is happening is the load should be of reactive, inductive, capacitive in nature. So capacitive nature means the capacitance said to be existing there itself, that has to inject the reactive power into the network. That is the observatory that what you can have is next. Next, transient phenomenon. I told you one thing is that one is in the transmission distribution you can have the four things. In that what is happening is you can go through this one is third category is the transient phenomenon. In the transient phenomenon you have to consider the question. A surge of 100 kV is travelling through the surge impedance of the 300 ohms. The line is terminated with the resistor of 100. Find the reflected component of voltage. So reflected component of voltage V dash is equals to R minus Z divided by R plus Z into what it is equal to V. Here R is equals to 100 minus Z is equals to how much it is 300 divided by this is equals to 100 plus 300 into surge is equals to how much it is being the 100 volts. So this is equals to minus 50 kV. That is the simple thing is that. Okay, the impedance matching is being there. Okay, if this terminated impedance and the surge impedance both are being the same, the reflectionless transmission is possible. Otherwise, it is not been possible. If both are same, R equal to Z बोले तो V dash equal to कितना हो रहा है? V dash equal to 0. V dash equal to 0, reflected component equal to 0. Reflected component equal to 0 means what is happening is, what is the incident value is totally gets refracted. Okay. That is the simple thing is, okay. I am telling you one thing is that the mathematical formulas are very important. For all the students who have attended the classes, for them I told to them thing is that one is भाई आप लोग एक 100 pages notes रखो, 100 pages ना अभी भी बोल रहा हूँ मैं आप लोग को, अभी भी बात है कि I don't know that one how many going to succeed in the 25 gate, so take the option of 26 also, अभी भी बोल रहा हूँ. जो टीचर कहाँ पढ़ाया था ना तो कोई टेक्स्ट बुक में आप देख रही हो, आपको तो बात है कि फार्मूलास नोट करो, सिर्फ फार्मूलास. सपोज द ट्रांसमिशन डिस्ट्रीब्यूशन इज देयर, उसके अंडर क्या क्या फार्मूलास आएगा. अभी मैंने सब्जेक्ट को किस लेवल पर किस डायरेक्शन पर डिस्क्रिप्ट किया था, उसी डायरेक्शन पे आप लोग कर लो. फार्मूलास ऑल द फार्मूलास नोट कर दो. एक हैंडबुक आपके साथ रहेगा, वो हैंडबुक में जो फार्मूलास है आप प्रैक्टिस करो. तभी क्या होता है कि जब भी कोई न्यूमेरिकल आता है ना, न्यूमेरिकल डेटा और लॉजिकल कंसेंस के हिसाब से हमारा दिमाग में बत्ती जलाना है कि कौन सा फार्मूला यूज़ करें. ठीक है, सो ये फार्मूला यूज़ करें तभी हमको चलेगा बोल के बोलने से बात है कि आपको तो एक अंदाज़ा और जानकारी अच्छी तरह होती है. तो इसलिए आप लोगों को मैं ये बोलता हूँ ये सब फार्मूलास है ना दिमाग में रख लेना. नेक्स्ट इज दैट व्हाट इज हैपनिंग इज a lossless long transmission line of length 200 km has a sending end voltage of 1 per unit. Find the voltage at no load condition. यहाँ भी आप बोलते हैं कि यहाँ भी आप बिना कुछ करके ओके आपको तो आंसर निकाल सकते हो बिना कुछ, विदाउट पुटिंग पेन एंड पेपर यू कैन डू इट. क्या बोला था? सेंडिंग एंड इज इक्वल्स टू 1 पर यूनिट. ठीक है, एट no load definitely what is happening is receiving end voltage is greater than sending end voltage at no load. ठीक है, so therefore what I can say this is the wrong answer, this is the wrong answer, this is also wrong answer. ठीक है, अब ये these are the two, both are greater but here the 2 per unit is there. Sending end voltage is 1 per unit, रिसीविंग एंड वोल्टेज इज 2 पर यूनिट. इसका मतलब क्या है कि एकदम ओपन सर्क्यूट. ओके, 100% राइज ऑफ द वोल्टेज इज देयर. कई बार मैं बोल चुका हूँ 100% ऑफ द राइज ऑफ द वोल्टेज इज नॉट द गुड डिजाइन ऑफ द लाइन. ओके, सो whenever the sudden open circuit is being there, then only it is being possible. Sudden open circuit is not the no load. Sudden open circuit if occurs, then only what's happening is the rise of the voltage will be, the double will be there. That is called the doubling effect. In the fault analysis you might have studied. How do you define the doubling effect? When a sudden open circuit or short circuit is being made, the maximum of 2 times the voltage rise can be observed. The minimum of 2 times the current rise can be observed. That is being called as the doubling effect. Okay. So this doubling effect will come not under no load condition, under sudden opening of the load. Okay, sudden opening of the load, this may be possible when the load is being totally thrown off. So therefore what is happening is this is also wrong answer. So what is the right answer? This is the right answer. ठीक है, राइट ये राइट आंसर है. साबित कैसा करें आप देख लो. कैसा होता है कि ये आंसर कैसा होता है कि देख लो ना. So I will tell you that one is okay. What it is said that one is voltage at no load, that is equal to V dash. V dash equals to what? Vs by A. Vs is already given. ये क्या होता है? A equal to 1 plus Yz by 2. So this equals to 1 plus Y क्या होता है? G plus j omega c into L. Z क्या होता है? R plus j omega L into L divided by 2. लॉसलेस लाइन बोला था ना. फॉर लॉसलेस लाइन क्या होता है? R equal to 0, G equal to 0. Then A equal to, this is 1 minus omega c into omega L into L square by 2. So here it is A equals to 1 minus omega c into omega L. ये क्या होता है? This equals to beta square into L square divided by 2. Lambda is equals to V by F, that equals to 2 pi by beta. This is a formula you can have is. So lambda means what? Velocity of propagation. Velocity of propagation of the electromagnetic radiation is V equal to 3 into 10 to the power of 5. I guess kilometers per second. ठीक है, this is the velocity of propagation is there. So therefore what is happening is by making use of this one is beta is equals to 2 pi by 3 into 10 to the power of 5. That you substitute the beta here itself, then you can get the A value as you can get the A value as 0.978. बिकॉज यहाँ स्पेस लिमिटेड है, इसलिए तो बात है कि सिंप्लीफिकेशन नहीं कर रहा हूँ. इसको तो यहाँ सब्स्टिट्यूट करो. L is equal to 200 kilometers has been given, no? 200 kilometers means you have to substitute 200 into 10 cube. That is because the reason is that what is happening is here, sorry, 200 square itself, because kilometers है ना ये. ठीक है, kilometers you have to substitute. Then what is happening is 0.978 A will be coming up. So this value that you substitute here, L is equal to 200 square. Okay, A will be like this. Then V dash equal to 1 point divided by 0.978. So that is equals to 1.022. देखा, बात है कि ये पूरा खोजने के बाद ये आंसर आया था, लेकिन एक चुटकुले में बता दिया था मैंने आप लोग को. बात क्या है कि किस तरह होती है. At no load, definitely VR is greater than Vs. So therefore, what I can say, this is wrong, this is wrong. ठीक है. Next, what is the thing that you have to go here is this is wrong, this is wrong. Okay. Next, what is the thing that you have to concern here is, okay, so these two are being there. The voltage will be, this one is the double the value will be coming up. So that is the under faulty conditions is being possible, not under the regular condition. So therefore what is the final thing is that one is, that is only the option that you can have is, and if you do the question also you got the same. Okay, next, a transmission line has a surge impedance of 250 ohms. This line is terminated to the inductor of 2.5 millihenries. Find the instant of time at which the line stands reflectionless. Beautiful question. ठीक है, termination of the inductance. Okay, termination of the line with the inductance. Normally what is happening is the termination of the line that you can have is, okay, so here it is the answer for this question, time t is equal to 0.692 into L by Z. Okay, so this 0.692 into L is equal to how much it is being given, 2.5 into 10 power minus 3 divided by 250. Okay, this equals to 6.92 microseconds. Okay, so where is the answer? 6.92 microseconds. A is the right answer. So this is the formula that what you can have is clear. That's what I am saying, that one is you have to derive the formula of your own in the examination hall, otherwise what is happening is it is not being possible. Normally what is happening here is, suppose if you take the termination with the resistor, you are having the formula that V double dash is equals to 2V by what it is, R plus Z into V. So with inductor, okay, so R is replaced with what it is being, that one is inductor. Okay, then what I can say here is, if you convert into Laplace transform, V double dash of S is equals to 2R है ना ये, हाँ sorry 2R, 2 into R की जगह क्या है L का मतलब क्या होता है, LS you have to substitute, divided by LS plus Z is the surge impedance is the resistive characteristic, so इसका Laplace transform वही रहेगा. So Z and V का क्या होता है, V by S. Suppose if you consider that one is V double dash of S is equals to 2V by S plus Z by L. That means V double dash of T is equals to what it is, 2V into e power minus ZT by L. This is a response, a refracted voltage for the inductance. Line is terminated with the inductance that you can have. Now what it is that line stands reflectionless means क्या होना चाहिए, V double dash equals to V होना चाहिए. Okay, that means reflection component equal to 0. So V double dash is equal to V. That means V equals to क्या होना चाहिए, 2V into e power minus RT by L. So if you take this T, that equals to, if you make a solution, this one is 0.692 into L by Z will come. So this is the part of the derivation that you have to do. Okay, gate examination में खासियत यही होती है. बात क्या है कि you have to derive your own equation. The equation will not be, sometimes maximum times what is happening is the exact equation cannot be done in the due course of a curriculum. You have to derive your own equation. As per that, what is happening is you have to get the solution like this. Okay. Next is a transmission line possesses the inductance of 1.1 millihenries, the capacitance of 0.1. Find the velocity of propagation of the wave in the line. Velocity of propagation V is equal to 1 by root over what it is, LC. So that is equals to 1 by root over, okay, L is equal to how much it is, 1.1 into 10 power minus 3 and 0.01 into 10 power minus 6. So put together it may become as 3 into 10 to the power of 5 किलोमीटर्स पर सेकेंड. आप लोग एक चीज़ दिमाग में रख लेना प्लीज़, मैं ये बोल रहा हूँ, फॉर दिस वन इज बाय डिफॉल्ट यू नीड टू कंसीडर मिली हेनरीज पर किलोमीटर एंड माइक्रोफैरड पर किलोमीटर. ओके, पर किलोमीटर यू नीड टू कंसीडर. ओके, आप लोग को मैं बार बार यही बोल रहा हूँ, बात यह है कि एक चीज़ दिमाग में रख लो, कभी भी ऐसा होता है कि किसी हाल पर वेलोसिटी ऑफ प्रोपगेशन शुड नॉट बी मोर देन 3.5. मैं आप लोगों को एक चेतावनी पहले दिया था. ओके, ये लेक्चर जब पढ़ाते वक्त आपको एक लिमिटेशंस बता देता हूँ. इसका मतलब है कि फॉर एनीथिंग द बाउंड्री फॉर द सॉल्यूशन. ओके, मतलब क्या है कि डेटा देख के भी आपको एक अंदाजा होना चाहिए कि द आंसर शुड कम equal or less than 3 into 10 to the power 5. If any answer comes more than 3 into 10 to the power 5, that is wrong. ठीक है, आंसर शुड कम इक्वल और लेस देन 1. इसका मतलब क्या होता है कि किसी कैलकुलेशन पर आपको तो पहले अंदाजे ऐसा होना चाहिए इसका आंसर 100 से ज़्यादा नहीं है, 100 से ज़्यादा नहीं हो सकता है बोल के आपको तो अंदाजा होना चाहिए. ओके, ऐसा चले तो अच्छी तरह चलता है. ठीक है, नेक्स्ट I'll go for this one. The HV lines are designed on the basis of switching surges. Okay, because the thing is that what is happening is switching surges are most dangerous. Okay, when compared to the this one is lightning strokes. This one is okay. In the lightning strokes can have the maximum of 1000 kV. Okay, but switching surges doubles. Okay, कैसे है? Switching surge means what is happening is that due to doubling effect it may become the double. Suppose let us say when the operating voltage is equals to UHV lines बोला था ना, UHV lines are greater than 800 kV. So greater than 800 kV means यहाँ तो switching surge इसका कितना हो सकता है, 2 into what is happening is 800. That means it is equals to 1600 kV. So switching surge for this line it can have the probability to rise the voltage up to 1600 kV. but whereas the lightning stroke is limited up to 1000 kV. So that is the reason what is happening here is okay, so it more concerns with the switching surge. That means what is happening here is operating voltage of 400 or less than 500, for them the lightning stroke is more intensified, but beyond that one what is happening is switching surges are more intensified. So that is the reason what is happening is answer is the switching surge. Okay. Next, a transmission line having the surge impedance of 300 kV terminated with a capacitance of 3000 picofarad. Find the time after switching that the refracted voltage equal to 150 while the incident voltage equals to 100 kV. That means what is happening here is he is saying that this is the source that you can have is okay, or incidence what you can have is okay. So incidence that what you can have that is the incidence, let me call incidence bus you can have. You are terminating the line with a capacitor like this. Okay, in this case what is happening is you can derive the network equation in such a that one is V double dash of t equals to 2V into 1 minus e power minus t by Zc. So here V double dash is given as a 150 and equal to incident voltage equal to 100. That means 2 into 100 of 1 minus e power, this is the time is required, minus t by Zc is equal to how much it is? Z is 300. 300 into what is the 3000 picofarads? 3000 into 10 power minus 12. So in this one variable, what is the t? The t you have to solve, and the t is equals to, what is the value of t is equal to 1.25 microseconds. It is also the same as you are having the V double dash is equals to 2R by R plus Z into V. No, here what is happening here is okay, the R की जगह में अब capacitance लगाए तो capacitance का impedance function क्या होता है 1 by CS. So that V double dash of S is equals to 2 into 1 by CS divided by 1 by CS plus Z into V by CS ले लो, इसका solution निकालो, if इसका inverse Laplace बनाओ, you will get this one is. Okay, so I'm saying the application of the networks. Two subjects are very important in the study of power system. One is the network, another is the control system. If you have a thoroughness in these two, you can do well anything. Okay. Next, design of power system. Okay, in the design of power system, the overall diameter of the standard conductor is equals to what it is? D is equals to 2n into okay, n minus 1 into d. It is a standard one, where n is the number of layers. Just a theoretical question. It is a standard one. Next is that one is expanded ACSR conductors are used for UHVAC lines. Okay, right? Because the thing is that one is between the aluminum strands and as well as the iron strands. Between them, what is happening is you are providing the thickness. So UHV lines is the application of this one is. Next, because the 130 kV transmission line possesses the corona loss of 1 megawatt, the operating frequency changes 75. Find the corona loss. We know one thing is that one is the power loss is proportional to F plus 25. So PL2 by PL1 equals to what I can say? What I can say F2 plus 25 divided by F1 plus 25. So PL2 is the thing you need to determine. PL2 is equal to PL1 is equal to 1 into initially F2 is this, second thing is 75 plus 25 divided by what it is 50 plus 25. So this comes as 1.33 megawatts. This is the right answer. This is the formula. I am saying one thing is that one is all the times what is happening, it is not the total formula is needed, total formula is to be accounted. Okay, you need to account that minimal level also. Okay, so which part to extract, by which part you need to make the calculation that you have to okay make this one it is. Okay, next. Okay, string in 3 insulators, voltage across the top disk is equal to 10 kV. What is the string efficiency? Simple question. Okay, we know one thing is that one is V2 is equals to 1 plus K into V1. क्या दिया था इधर? V1 is equals to 10 kV and V2 is equals to 13 kV. These things has been given. Now V2 is equals to how much it is being? 13 equal to 1 plus K into 10. So by this way you can take K equal to 0.3. Then V3 is equals to 1 plus 3K plus K square into V1. So if you substitute the V1 and K value, you can get it as a 1.99 V1. Then the string voltage Vs is equals to 1 plus 199 this is equals to 19.9. So Vs is equals to 10 plus 13 plus 19.9. This is equals to how much it is? A 42.9. So percent of string efficiency is equals to Vs divided by N into Vn. Okay, so that is equals to percent of string efficiency in this string efficiency. Otherwise, what's happening is you can directly write it as a 3 into V3 because the 3 strings are there. No, you can write it as a 3 into V3 directly. You can write it. So thereby, this equals to 42.9 divided by 3 into 19.9 into 100. So this comes around 71.85. The calculation. Okay. See here also I can say the same thing is that one is okay. 100% will not be there. 85 के लिए क्या होना चाहिए? K to be less than 1.1. Normal design is that one is K is always to be less than 0.1. That means K to be less than 1 by 10. Then only what's happening is you can get the string efficiency to be more than 85%. Which one of the following method to improve the string efficiency? Okay, string efficiency longer. Okay, improve the string efficiency is more effective by using the longer cross-arm, by grading, by using the ordering, by horn gap. Okay, actually this one are the 3 methods are there. Out of these 3, it is the most effective because normal. Okay, so this one is. So we know one thing that C is inversely proportional to V. So therefore CV equal to constant. CV equal to constant means what? CV is equal to Q. Q constant means charge constant means current constant. Current constant means current throughout all the discs will be the same. Current through all the discs is the same means what does it indicate? What does it indicate? It indicates that one is bypassing current or the shunt capacitance effect is negligible, nullified. Shunt capacitance is nullified means what's happening is the maximum to maximum string efficiency is being possible. So that is the reason what's happening is okay, that is the reason the grading method is being the most effective one when compared to all the other. Okay, grading is the most effective method. Longer cross arm, ordering, okay, they cannot, they can also subsidize, but what is happening is they cannot that much subsidize as this ordering is causing, grading is causing. Okay, next. A single core cable has a diameter of 1 centimeter and the insulation thickness of 0.4. If the specific resistance of the insulation is equal to, then calculate the insulation resistance for 2 kilometers of the length of the cable. So insulation resistance Ra is equal to rho by 2 pi L into Ln R2 by R1. It is a simple substitution. Rho is given as how much it is being 5 into 10 to the power of 14. L is given as the 2 kilometers. Here R1 is equals to single core cable conductor diameter. Core diameter is equal to, that means D1 by 2, that equal to 1 by 2, that equal to 0.5. R2 क्या होता है? R1 plus thickness T, that is equals to R2 means cable diameter, total cable diameter. It is not the core. Thereby this you can write it as 0.5 plus 0.4, that equal to 0.9. That you substitute here. If you substitute here, this equals to 5 into 10 to the power of 14 divided by 2 pi into length. Actually it is the 14 है ना? Okay, sorry. Ohm cm में दिया था ना, therefore this also you have to convert into meters, so centimeters. That is equals to 2 into 10 क्यूब, यहाँ तक मीटर्स हो गया, और इंटू 10 स्क्वायर, ओके, किलोमीटर, यहाँ तक सेंटीमीटर्स हो गया, इंटू व्हाट इज हैपनिंग इज ln 0.9 by 0.5. So this would be equal to 229 mega ohms. Say some kind of a questions I have given in the mode of multiple objectives, in some kind of I have given as the questions, so that what is happening is all the times guess or this one is a conceptualization is not being valid. So that is the reason for such kind of the questions you have to make the numerical analysis like this. It is a simple substitution that you can have is through this mathematical formulation. What do you know? That one is insulation distance is inversely proportional to the length. That is should be the understanding you should have. Next you can have this one is the insulation distance of a single core cable is equal to 495 mega ohm per kilometer. If the core diameter is equal to 2.5 centimeters, then the resistivity of insulation is equal to 4 into calculate the thickness of insulation. Yes, here also what is happening is the core diameter has been given, that one R1 is equals to D1 by 2, that equal to 2.5 by 2, that equal to 1.25 centimeters. Here also you have to recall the same formula, Ri equal to rho by what it is 2 pi L into ln R2 by R1. You make the substitution of all, 495 into 10 power 6 mega hai na, that is equals to rho is given how much, 4.5 into 10 to the power of 14 divided by 2 pi L, 2 pi L per kilometer bola tha na. So therefore what is happening is 1 into 10 cube into 10 square ln R2 by R1. So from here you can take ln R2 by R1 is equals to what you are getting here is 0.688. That means R2 by R1 is equal to e power 0.688, that is equals to 1.989. Thereby what is happening is R2 is equals to 1.989 into 1.25. So that is equals to 2.5. Then thickness is of insulation R2 minus R1, that 2.5 minus 1.25, this equals to 1.25 centimeters. So these are the standard model of the questions that you can have from the cables, okay. So sometimes the insulation distance will be given, sometimes by the calculation of the R1 and R2 the thickness will be given, or sometimes by giving the thickness you may ask the R1. See, I am telling you the one thing is that this is the very important numerical concern. Based on this one what is happening is by changing the variables here and there any kind of a questions may be possible. Okay. Next, portion operation control. Okay, in this what is happening is you are going to discuss the load flow analysis, economic load dispatch, control problem. These are the things that what you are going to discuss in this module. These are the topics that you can have is. Okay, first we are going for the load flow analysis. In the load flow analysis the question has been given this, find the Weber's matrix for the following configuration. Here we know one thing is that one is the fundamental concern of the Weber's matrix is the size of the Weber's matrix is equal to 3 n cross n. N cross n means n is the number of buses. Here how many number of buses are there? 3 buses are there. Namely, you name them as 1, 2 and 3. Here you can see one thing is that one is here the line impedance has been given in the J's. That means it is been given in the impedances. Okay, most of the people as it is been given they are thinking that one is it is the admittance. No. Thing is that line impedance can have the positive this one is a reactive component, okay, so imaginary component. So this to be taken as a 1 by that is equal to minus J10, this also to be taken as minus J10 and this also to be taken as a minus J10 and this is to be taken as a minus J4. 0.25 and 4 it is. And these are the capacitive impedances. The capacitive admittance is always plus j, inductive admittance is only minus j. So as it is given in the inductive impedance, that is the reason what's happening is you have to convert into admittance. यहाँ तो बहुत सारे लोगों को problem होती है. So here only then what's happening is as it is given directly they are taking on the line is always be ध्यान से सुनो, line is always be provided with an impedance of r plus jx, z equal to. So line impedance में plus j आ गया तो admittance में ही क्या है कि minus j आएगा. अगर यहाँ माइनस जे लिखे तो ठीक है, यू टेक इट एज एडमिटेंस, बट प्लस जे लिखे तो बात है कि यू कैन टेक इट सिंपल. आई विल टेल यू इसका एडमिटेंस होना चाहिए, क्या होना चाहिए 1 बाई आर प्लस जे एक्स, दैट मीन दिस इक्वल टू जी माइनस जे बी. इसका मतलब क्या होता है कि ओके कोई भी लाइन में, इधर लिखता हूँ, कोई भी लाइन में ऐसा दिया था 2 प्लस जे थ्री, रीड इट एज व्हाट इट इज आर प्लस जे एक्स. कोई भी लाइन में ऐसा दिया था 2 माइनस जे थ्री, रीड इट एज जी माइनस जे बी. अगर लाइन का रिप्रेजेंटेशन ऐसा होता तो आप आर प्लस जे एक्स ले लो, लाइन का रिप्रेजेंटेशन ऐसा होता तो जी माइनस जे बी ले लो. ठीक है, here the plus j is there, that is the reason what's happening is you have to convert into admittance form. Now you have to open the box of admittance. Okay, from this what's happening is here it is 3 by 3 will come. What is the 3 by 3? Some of the admittances first what the thing is we can have this one is admittance that you can have is the y11, y12, y13, y21, y22, y23, y31, y32, y33. This is the matrix that what you can have is okay. ठीक है. Now the answer you have to get it in what way? y11. What is the y11? Some of the impedance connected to the bus number 1. What are theirs? This plus this. How much it is? Minus j plus minus j10 minus 20 plus 1 equal to j minus 19. y12 negation of the original existing value, that is equals to j10. 13 negation of the original existing value, that is also j10. And y21 negation of the original existing value, j10. y22 some of the impedances connected to that bus, this is minus j10 minus j20 plus j1 minus j19. 23 negation of the original existing value, that is equals to j10. Next what other thing is okay 31 negation of the original existing value, that equals to j10, and this is also j10 and minus j summation of all, how much it is minus j24. So this is the fibers that what you can have is okay. In the framing of the fibers by inspection there are two rules are there. Okay, every matrix is formed with the two type of elements, diagonal, off diagonal. For all the diagonal, the rule of concern is that one is it is equal to the sum of the admittances connected to that bus. For all the off diagonal is it is the negation of the originally existed value, negation of the originally existed value. ठीक है. Next given the fibers matrix at which buses the shunt elements are existing, what nature they are. ठीक है, very good question it is being. गेट में ना, गेट में दो प्रोबेबिलिटीज बहुत ज़्यादा होते हैं, एक वाई बस और एक जैकोबियन मैट्रिक्स. ये डिस्क्रिप्टिव क्वेश्चंस ऑफ द लोड फ्लो ऐसा ज़्यादा नहीं आएगा. So that is the thing is you have to concentrate more on this one is in the shortcut methods and all. You can go through this one is if you make the summation of this one is you are getting the minus j2 is the summation, you are getting the 0 as here, you are getting the plus j2 is the summation. So if you make the row or column summation, the remainder if equal to 0, that indicates there is no local load or shunt element. If the remainder is not equal to 0, that indicates the existence of local load or shunt element. This is the rule that what you can have is okay, right. So the remainder is existing at the first column or the first row or third column or the third row. The therefore what is happening is at which buses the shunt elements are existing. So your answer is fundamentally 1 and 3. For this bit, the answer is 1 and 3. For this bit, what nature they are? Minus J2 आ गया ना? It is an admittance. Admittance का minus J होते तो क्या होता है? This is of inductive in nature. Plus J क्या होता है? This is of capacitive in nature. That you are understanding. Okay. So class में जब पढ़ाते वक्त मैं बता देता हूँ. बात क्या है कि the summation of the row or column equal to 0. That means there is no remainder, that indicates that there is no local load or shunt element. If the summation of row or 0 is not equal to 0, the remainder existence of the remainder indicates that their existence of a what is happening is a shunt element or local load. If that remainder imaginary component is positive, that indicates the load is of capacitive nature. For the remainder, the imaginary component indicates as a negative, that indicates the inductance. This is the rule I used to tell me let in the class while you are writing the Y-bus matrix. As for that, what is happening is we can make the things like this. See, I am letting you one thing is this class you have to concentrate utmost, because the thing is that is generally क्या होता है कि आपको 4 साल इंजीनियरिंग में जितना पढ़ते हैं कि ये 120 आवर्स में हमारा पावर सिस्टम क्लास में हो जाता है. 120 आवर्स में जितना होता है उतना ये 3 घंटा में हो रही है. ठीक है. So therefore what is happening is this 3 hours of lecture equal to 120 hours of regular mandatory lecture, and that is equal to 4 years of your engineering. So ध्यान से सुनना. ठीक है. Given the Y-bus matrix equal to, then what is the specific featuring in this matrix and specify. Yes, normally I will take that one is Y-bus I will take like this. This equals to A, B, C, D. Just I will take like this. Okay, what it is case 1, if A equal to D, B equal to C, normal form. मतलब with resistance and reactance. Second thing is that if A equal to D, A equal to ऐसा लिखो modulus of A equal to modulus of C like this. A equal to D and B equal to C only. Not all the 4 are same. These 2 are same. These 2 are same. Okay. With line charging impedance means that one is with capacitance, that means R, X, C, all the 3. Number 3 is that if A is not equal to D but B equal to C, okay, with tap changing transformer. Okay. Fourth one is if A is not equal to D and B is also not equal to C, what I can say, with the phase shifting transformer. These are the 4 cases I used to tell in the class. Okay, the writing of the Y-bus can be done with these 4 cases. Normal form means line has resistance and inductance only. Okay, with line charging impedance means along with the resistance inductance, capacitance also included. Next, tap changing transformer is what is happening is along with the impedance, tap changing transformer is also there. Along with the impedance, phase shifting transformer also there. So these are the 4 forms that you can have is. Okay, when these 4 forms have been there, okay, then only what is happening is these are the 4 ways, 4 case studies that you have to make in writing the Y-bus matrix. Normally most of the people will tell first one and second one, third and fourth छोड़ देते हैं. Third also some people, but fourth किसी को मालूम ही नहीं है. There is a book is being there. Okay, caps बोलते हैं. हाँ, बीच बीच में इस लेक्चर में मैं आपको कुछ टेक्स्ट बुक के बारे में बता देता हूँ. वो भी आप थोड़ा नोट कर लेना. कंप्यूटर एडेड पावर सिस्टम एनालिसिस बोलते हैं. इसको क्या बोलते हैं? कैप्स बोलते हैं. ओके, सो इन दैट कैप्स व्हाट इज हैपनिंग इज दिस बुक इन द कैप्स में ये 4th केस दिया था. राइट, सो देयर बाय व्हाट इज हैपनिंग इज according to this data that what I have presented to you, this Y-bus is belongs to the 3rd case. What it is? A is not equal to D but B is equal to C. A is not equal to D. That means that what is happening is the tap changing transformer is there. So with the tap changing transformer, what is the Y-bus matrix you can have is this is Y12 divided by A square, Y12 by A minus Y12 by A, and this is y12. So therefore, what is happening is what is the special featuring means off nominal ratio. Okay, special is of nominal ratio. What is that? A. The special featuring means what is happening is off nominal ratio A. So how do you get the A? A equals to, how can you get? y12 by A. So that is equals to 2.5 divided by 2.38, that equal to 1.05. Maximum off nominal ratio you can have as a 1.05 only. Okay, so that is the thing that occurs. First is inductor, third is capacitor. It must be correct. So this is the way that what you can have is off nominal ratio बोलते हैं. So that is the one is. This information is very important बाबू. आप लोग बात है कि नोट कर लेना. Okay, अगर कोई डाउट अगर स्पेशली होता तो मेरे लिए मुझको ना स्पेशल डीएम कर देना. मैं फ़ोन नंबर देता हूँ और फ़ोन नंबर में बात है कि आप मुझे डीएम कर दो. मेल आईडी भी देता हूँ, उसमें तो बात है कि आप मुझसे कांटेक्ट कर सकते हो, कोई प्रॉब्लम नहीं है. ठीक है. At any student, anyone watching this live can interact with me, no problem. So this is the thing that you can have. Is special featuring means what's happening is off nominal ratio. The value of the off nominal ratio is equal to 1. See, गेट का क्वेश्चन ऐसा ही होता है, प्रिसाइज होता है, लेकिन इसमें बहुत सारी चीज़ें होते हैं. आप देख लो, हर डिस्क्रिप्शन बहुत छोटा हो रहा है, लेकिन आंसर तो बहुत लंबा हो रहे हैं. Conceptually, I am telling you every question I am giving in a conceptual mode. So that is a very important thing that you have to observe. Next is the what is happening is a power network consists of 25 buses in which there is one slack bus, 5 generator buses, remaining all are load buses. Find the number of equations required to conduct the load flow in NR method and in this one is NR method and this one is. Now what is the thing that you can have is in the Gauss-Seidel method, ध्यान से सुनो, V dash equal to E plus JFP in a rectangular form that you are getting the solution. In the rectangular form you are getting the solution means what is happening is one rectangular solution to get one equation is sufficient. Therefore what is happening is here how many buses are there? 25. Slack bus के लिए equation डालते नहीं हम, because the thing is that one is the aim of the load flow is to calculate the V and delta. At the slack bus both V and delta are specified. That is the reason what is happening is you need not make a you need not put the equation for the calculation of the slack bus. Okay, that is the reason 25 minus 1, that is equals to how many it is being the 24 bus. That means to write the 24 equations you can have is in the NR method you are getting the V separately and delta separately. For V separately you are calculating a delta separately. That means that what is happening is for each bus you have to put the two equations. Each bus you have to put the two equations here is, here let us take the data is slack bus is equals to 1, generator buses is equals to 5, then load buses is equals to how many? 19. Okay? So therefore what is happening is V and delta, and for the generator bus here what is happening is your interest is to calculate both V and delta, and your interest is to calculate the delta only. Here what is happening is V and delta are specified, therefore nothing to be calculated. So therefore what is happening is for this one is the answer is 5 deltas plus what is happening is 19 into 2. Okay, how much it is? 43. Okay, so this is the thing that what you can have is, this is the thing that what you can have is, right. So thereby 43 is the answer that what you can have is. Clear? 43 equations are required for the, okay, so you have to convert into this one here is okay. So 43 equations are required. Okay, that is the differentiation that what you can have is in the NR method and as well as the Gauss-Seidel method. Okay. So for each load bus, or whether it is the load bus or generator bus, definitely you have to put one equation for the Gauss-Seidel method. if it is being the Newton-Raphson method, in the Newton-Raphson method what is happening here is two equations are separately written, one for the V and one for the delta. So that is the reason what is happening is for the 19 load buses, one V, one delta, that is equals to 19 into 3, 38, and for this one only 5 into 1, 1, okay, 38 plus 5 equal to 43 equations are required. Next is that one is in a system of 200 buses, there is a slack bus, 20 generator buses, 10 reactor buses, 5 dampers, and remaining all are load buses. Find the size of the Jacobian. Actually, thing is that what is happening is here for the size of the Jacobian, you are writing that one is Jacobian size is equals to 2n minus m minus 1 into 2n minus m minus 1 is the equation that you are writing. ठीक है, 2n ध्यान से सुनो, this is a very complex question, very important question. 2n you are taking in sense that one is okay, for each bus there are two variances are there, okay na, so in that way you can take it. In that way if you take, this is equals to 2 into 200, okay, minus m, number of buses whose voltage magnitudes are specified. So here 20 generator buses whose voltage magnitude are specified, plus one slack bus specified, minus 1 is there, across you can take it 2 into 200, okay, minus 20 plus 1 minus 1. So therefore what is happening is the fundamental answer to be 378 cross 378. This is the fundamental answer. सब लोग बात है कि यही आंसर बोलते हैं, लेकिन आप एक चीज दिमाग में रख लो, द पॉइंट इज दैट वन इज टू, ध्यान से सुनो, दिस इज वेरी इंपॉर्टेंट, आई एम सेइंग दैट वन इज ओके. कहीं पर आपका अभी तक सुना है कि मेरा क्लासेस जो आया था वो सुना होगा, लेकिन बाकी लोग के बारे में बता रहा हूँ. Okay, so thing is that what is happening is you can understand the thing is that here very crucial and very important point is being there. So please pay concentration here in getting the thing. So what is that here is, you can observe one thing is that 2n you have taken in such a way that one for each bus there are the two variations are there. In each bus there is a two variations are there. But you see one thing is that one is 10 reactor buses and 5 dampers. Reactor buses means that is for the control of reactive power, that does not have any job with the active power. Damper means to regulate the active power, does not have the concern with the reactive power. That means that what is happening is, here the deviation of the reactive power is not admissible, here the deviation of the active power is not admissible. Okay, so that is the reason what is happening is, for this 5 and the 10, one entry will be there. That is the reason what is happening is, this equation to be modified like this, J equal to 2n minus k minus m minus 1 cross 2n minus m, 2n minus k minus m minus 1, where k is number of buses at which only one quantity to be specified. Accordingly, this is 2 into 200 minus k कितना हुआ था, 10 plus 5 minus 1 plus 20 minus 1 cross 2 into 200 minus 10 plus 5 minus 1 plus 20 minus 1, that is equal to 363 cross 363. Once again I am telling that one is, this 2n generally you are taking at each bus, two variations are been possible. But the reactor buses at which delta Q only possible, delta P is not existing. At the damper buses, delta P is only existing, delta Q is not existing. So that is the reason for these buses, two equations will not come, one equation will come. So thereby what is happening is, in the previous question, linking to the previous question, you can get the better answer. Okay. Next, specify the bus at which the delta is only specified, that is the slack bus. Slack bus is only the bus at which the delta is specified. In other buses, delta is not specified. Next, one of the which method is more accurate. Okay, thing is that what is happening is, see, FDLF GS method से भी NR method better है. FDLF is approximated on the NR. Static load flow means what is happening is static load flow is the concern. It is another form of the Gauss seidel. So that is the reason what is happening. The best answer is the Newton-Raphson. Variable tangent can be considered in which type of load flow? Dynamic load flow. Variable tangent means slack bus can be changed. Alteration of the slack bus is been possible in which method means in Newton-Raphson. The selection of slack, dhyan se suno, selection of slack influences the convergence in the Gauss seidel method. So that is the reason what is happening is okay, in the Gauss seidel method slack bus has been fixed. Slack bus has been fixed means it is a fixed tangent. Variable tangent means slack is not being fixed, it is changing from time to time. So variable tangent that is been accessible with the Newton-Raphson method. Okay, therefore what is happening is the dynamic load flow, okay, is the answer. Okay, state nahi hai, static load flow. Static load flow mein variable constant. DC load flow is also one kind of the static load flow because you are assuming the active power P only. That is the thing, yes. Next, incremental characteristics of the two plants are given like this. Okay, na? So this question can move like this. Okay. Then what is happening is he is asking that one is ELD for lambda equal to. We know one thing is that one is for lossless ELD. What is happening is IC1 equal to IC2 equal to lambda. Then what is happening is if you make an equation of 25 equal to 0.02 P1 plus 17. Okay, so how much it is? P1 is equals to 400. Okay, and the other thing is that what's happening is 25 equals to 0.06 P2 plus how much it is? 19. So by this way P2 is equals to you can get 100. Okay, so the answer is 400 and 100. Simple question. We know one thing is that one is in economical scheduling you are having the very simple questions, so simultaneously equations, all the questions you can have is. Okay, next is that one is given the final characteristics. Okay, this one is optimum scheduling for this unit is. This is a super question, very excellent question. You please pay concentration on this one is excellent question it is been. Okay, I think that one is so far you might have studied this one or not, I don't know, but you can assess like this. The cost formula F you can write like this. What is one is A plus BP plus CP square rupees per hour. Okay, if dhyan se suno, this question is previous question simple one, but everybody I am saying that one this question is being the very very important. Please pay concentration. Okay, if what I can say, if plant runs for how much time? T hours. The plant runs for T hours. Then what I can say? FT total cost is equals to how much it is? A plus BP plus CP square into T. Okay, na? This one. Now you can see one thing is that one is this one is clear. We know that one is energy equal to power into time. Therefore, time T is equal to E by P that you can have is. Then FT equals to A plus BP plus CP square into what it is? E by P. Okay, let P dash is optimum. Optimum scheduling बोला था ना, P dash is optimum. Then FT equal to A plus B P dash P star plus C P star square to E by P star. Okay, at optimum cost to be 0. Then what is happening is DFT by DPI. Okay, क्या होना चाहिए? At optimum, this is the condition that you can have is Thereby, what is the thing that you can say is, okay, if you make this one is, you are getting like this, P star is equals to root over A by C that you can have, that equals to root over 510 divided by 0.00142, that equal to 600 megawatts. This is the absolute question. I am telling you one thing is that one is this kind of the derivations that you have to done. Okay, so okay, so thing is that what's happening is you can understand the thing is that here you can assess one thing is that this derivation you have to make your own by this kind of a questions. So thereby what's happening is you have to make your own. That is the reason if you are not enough of conceptually depth, then what's happening is not sufficient. That is why ever the time I am letting you people to go through the textbooks. If you go through the textbooks, then what's happening is you can know the things in a better manner. So please pay concentration in that and getting the things in that way. So if you make this one is what is the thing that you can have is minus AE by P square, that equal to CE will become. This you can make it as a limited space is being there, that is the reason. If you make the manipulation of this one, then you will be getting the P star is equal to root or A by P. If you know that formula, you can directly get it. Otherwise what's happening is to derive this one, you have to make use of the mind much more. Okay, two plants with ELDP1 as the loss coefficients, this one is, and find the penalty factors. Okay, so PL is being given as B11 P1 square plus 2 B12 P1 P2 plus B22 P2 square. So dou PL by dou P1, that is equals to how much? It is 2 B11 P1 plus 2 B12, what it is P2, that is coming as that is coming as a 0.14. Next dou PL by dou P2, that equals to 2 B22 P2 plus 2 B12 P1, that is coming as a 0.16. So PF1 is equals to 1 by 1 minus dou PL by dou P1. So that is equals to 1 by 1 minus 0.14. So 0.14, that is equal to 1.162, and PF2 equal to 1 by 1 minus dou PL by dou P2. So that is equals to 1 by 1 minus 0.16, that is equals to 1.19. Okay, so therefore what is happening is 1.16 to 1.19. This is the right answer. It is a simple substitution that what you can have is, okay, right. Next. Therefore we are for this one is, okay, that means that what is happening is capacitor has to compensate the total reactive power. Then what is happening is C is equals to how much? 75 VAR, that means QC. The capacitor, okay, what is happening is means that what is happening is here it is like this. This is the source that you can have is this load is there. This load is absorbing, what is the capacity it is absorbing? 100 watts of active power, 75 VAR of reactive power. Then he is saying that what is the value of the capacitance to be kept here itself. The current coming from here, it is a zero phase shift. The current coming from that zero phase shift means the source should not supply any reactive power. The current coming in zero phase shift means the source should not supply any reactive power. The source should not supply any reactive power means the total reactive power required by the load should be compensated by the capacitor itself. Therefore, what is happening is the total load absorbed reactive power of 75 VAR to be compensated by the capacitor means capacitor reactive power is like this. Then what is happening is the QC is equals to QC by what is happening is V square into omega. So this is equals to 75 divided by 250 square into 2 pi into 50. So this equals to 3.82 microfarads. Here, more than the calculation, logic is very important. In every question what is happening, the calculations are found to be very simple, but the logic is being the difficult and tough one. So that is the reason what is happening is you have to make the concern in a logical way. Okay, the current coming from the source is at zero phase should mean the source should not supply any reactive power. The source should not supply any reactive power means what is happening is okay, it to be totally compensated by the capacitance itself. Okay, so that is the concern that what you can have is okay. Okay, a power system is rated of 120 1250 megawatt. The damping coefficient is 1.2%. Normal frequency is equal to this one. Suddenly decreasing the static deviation. So the formulation that for this one what is delta f ss is equals to minus m divided by d plus 1 by r. So here m is equals to how much? Minus 50, and d is equals to what it is. How much it is being given, that one 1.2 percentage. That means 1.2 divided by 100 into 1200 divided by 1.0 divided by 100 into 50. Okay, so what is the damping coefficient? Percentage change in the load when the load is changing from for every 1 percentage change of frequency. The damping coefficient D is indicating that one is it is the percentage change in the load, okay, for every 1% change in frequency. So by this way the value of the D can be estimated as 28.8. Okay, so what is the first thing is been given, that one is okay, and the case A, okay, open loop, and there is no speed control means it is open loop. Open loop में क्या होता है? Loop gain 1 by r equal to 0. Then del f ss is equals to minus of minus 50 divided by what it is 28.8. The deviation is equal to 1.736 edge. ठीक है. Next B with what it is at r equal to 5%. That means r equal to del f by what I can say del p, change in frequency, that is a 5 by 100 into 50 divided by 1200. That means here you required is a 1 by r, that equals to 1200 divided by 5 by 100 into 50. So this is equals to 480. Then what is happening is in the substitution that you can have is del f ss is equals to minus of minus 50 divided by 28.8 plus 480. So this is equal to 0.0982. It is a standard question. Okay, I am saying one thing is that one is the questions which are being taken, all these are being the standard questions. See, these questions are selected, segregated in a way that one is what is the data is available from the various topics. Okay, suppose the load frequency control is there, in that what data is available, what control to be adapted. Okay, control of power is there, in that control of voltage is there, in that what data is available, what kind of a logical concern that you can take it. Accordingly what is happening is I am letting all these things as for the concern of this data type and data, I am posing this one is. Okay. Next is two generators of readings 200 megawatts and 400 megawatts are connected in parallel to share a common load of 600 megawatts. The regulation coefficients of 4% are 1. Find the load sharing with a common operated frequency. So in this, what is the thing I can say here is, here it is R1 is given as a 4%, that is equals to 4 by 100 into 50 divided by 200. So this is equals to 0.01, and R2 is equals to 5%, that means 5 by 100 into 50 divided by 400. So this is equal to 0.00625. Let X be the load shared by machine 1, then what I can say, R1 equal to del F by X, that is equals to how much it is, 0.01. Therefore, del F equal to 0.01 x. This is the one equation. R2 equal to del F by 600 minus x, that equal to 0.00625. From this, what you can write? Del F equal to 0.00625 into 600 minus x. This is your second equation. By solving 1 and 2, what you can say? By solving 1 and 2, you can get x is equals to how much it is been? 231. That means load shared by machine 1, how much? 231 by machine 2 is equals to 369 megawatts. Okay? This is also a standard question. It may come in your synchronous machines also. It is a common question. Then what is the thing is the frequency F2 is equals to F1 plus del F. Here the load is exactly equal, no? The del F to be taken as a negative. That is a 50. Del F कितना होता है? Del F is equals to 0.01 into 231. That equal to 2.31 minus 2.31. That equal to 47.69 hertz. Okay, this is the thing that you can have is, okay. So by this way, common thing here, the del F is equal to negative. What is the reason for the del F is negative here is, you can see one thing, otherwise what's happening is, if I take the F2 equal to F1 plus delta F, that means 52.31 aate hain. Both the machines can have the total capacity of 600 while they are delivering the load of 600. The maximum operating frequency may be 50 Hz. But here कितना हो रहा है? 52.31 हो रहा है. Okay, the frequency to be more than the normal frequency. इसके लिए तो क्या होना चाहिए? Load to be less than the installed capacities. That means that when there is a possibility of the total load is being less than 600, then there is a possibility of the frequency to be more than 50 Hz. Otherwise, it is not been possible. So thereby what's happening is, here the load and this one is being equal. Exactly क्या होना चाहिए? 50 होना चाहिए. Exactly 50 होता है तब होता है कि when both the regulation coefficients are being the same. If the regulation coefficient is being the more, then it is not been possible. Okay, right. Next, you have to go for the power system stability. So nothing is that what is happening is, in a 3-phase star connected alternator mechanical input of force and find H and M. Okay, so what is the thing that you can do here is, kinetic energy Ke equal to G into H. H is equals to Ke by G. So that is equals to 480 divided by 120, that equals to 4 megajoules per MVA. And M is equals to what? GH by pi F. So that is equals to 480 divided by pi, you need to substitute in radians, 1.16. Sometimes specifically they will ask to substitute in degrees, then you can substitute degrees. Otherwise what's happening is, you have to substitute them in radians only. That is equals to 3.055 megajoule second per radian. This one is simple question. It is been. Next is swing together. Swing together means what's happening is, it is equal to H1 plus H2. So that is equals to how much it is? 10 plus 15, that equals to 25. Do not swing together means H1 H2 divided by H1 plus H2. So that is equals to 10 into 15 divided by 10 plus 15, that equal to 6 megajoules per MVA. Okay. Next, the power system. Okay, so here what is happening here is, H equivalent you have to get it. H equivalent is equals to, what is happening is, sigma GH divided by G. So this is equals to, how many are there? 2. 2 into 300 into 6 plus, these are how many are there? 3. 3 into 200 into 4 divided by how much it is? 500. So this is equals to 12, I think. 12. This is 12 megajoules per MVA. ठीक है, this is the term that what you can have is okay ना. Next is that one is a reactive variable midpoint of the line. Okay, so this you can go through the further. Array. Here it is okay. Fault occurs at any bus. Find the delta CR. Fault if occurs at any bus. This question is also very good question. That what you can have is okay. So इसको I think blank document is there. ठीक है, वो क्वेश्चन यहाँ कर लेता हूँ मैं. बात क्या है कि इसका स्पेस चाहिए. नेक्स्ट विल गो फॉर दिस वन इज डेल्टा सी आर इज इक्वल्स टू कॉस इनवर्स ऑफ पाई माइनस डेल्टा नॉट इंटू पाई माइनस 2 डेल्टा नॉट इंटू साइन डेल्टा नॉट माइनस कॉस डेल्टा नॉट. So here delta naught is equals to, as per the concern, you can get it at 30 degrees. Okay, because the thing is that at equilibrium, PM at equilibrium, PM equal to PE equal to 1, that equals to EV by X sin delta naught. So that is equal to 1.0 equal to 1.2 into 1.0 divided by 0.6 into sin delta naught. So from this you can get the delta naught equal to 30 degrees. So 30 degrees means what's happening is it can come the value of 0.523 radian. ठीक है, time is running, that is the reason I am a little bit hurry. Cos inverse of pi minus 2 into delta naught means 0.523 okay into sin 30 minus cos 30. So this comes around 79.5 okay, 79.5 degrees. You can understand one thing is that what is happening is normal operation के लिए डेल्टा कितना होता है कि 30 to 45 degrees normal operation. That is the reason what is happening is critical clearing angle कभी भी 45 से कम नहीं होते हैं, कभी भी 45 से कम नहीं होता है. Critical clearing angle delta CR should always be in the range of 45 degrees to 90 degrees. अगर किसी ने stupidiously अगर ए दिया है तो delta CR okay, you can definitely you can condemn. So definitely you can condemn this one is okay. Delta CR never be less than 45 degrees. It is in the range of 45 to 90 degrees. So that's why ever the time you can observe that answer should be. I am telling you one thing is that पहले से मैं बोल चुका हूँ बात है आप लोग को. बाउंड्री दे देता हूँ हर क्वेश्चन के एक सॉल्यूशन के एक बाउंड्री होते हैं. सो अकॉर्डिंग टू दैट बाउंड्री व्हाट्स हैपनिंग इज यू कुड बी एबल टू गेट द थिंग इज ओके. सो दैट इज द वन you can get it. Next is that one is the 3-phase alternators rated anywhere with it fault analysis के लिए आया था हमने. Next question is the fault analysis okay, right Muzwar. And one more thing I want to tell you okay, suppose in this question if it is being given that one is suppose if the 3-phase fault is occurred at the middle of any one of the line, what to be the delta CR. So in that case the delta CR should be definitely be less than the delta CR in this case. मतलब बात है कि आप घर में एक काम करो, यहाँ भी फॉल्ट अक्कर हो गया, बीच में फॉल्ट अक्कर आ गया बोल के आप कैलकुलेट करके ओके उस जो फार्मूला वगैरह है ना उसे कैलकुलेट करो, उसका आंसर तो 79.5 से कम होना चाहिए. Reason is that what is happening is in this case when the fault is occurred at the bus, what is happening is the electrical power is totally equal to 0. Electrical power totally equal to 0 means what is happening is the machine makes the maximum acceleration. So therefore it has to deaccelerate, it will take more time. So that is the reason delta CR when the 3-phase fault occurs at the bus is more than when the 3-phase fault occurs at any point on the line. That is the observation, that a very important thing that you can have is. Again and again I am saying that one is, it is actually thing is that what is happening is, this thing is been working out for the people who have attended the class as a recap, this is okay. But what is happening is, I am sure that one is some people not attended any class, just you are watching this one is, it is not sufficient, okay. So you need to consider. 3 alternators reactants are connected in parallel to bus bar. 3 faults occur the bus, find the fault current. So we know one thing is that fault current IF is equals to VPF by Z equivalent or I equivalent into I base. So you have to take the base current here. The base current here it is equals to how much it is? 10 into 10 cube divided by root 3 into what it is? 11. So, okay, so this base current is equal to 5248 amperes. Okay, now you see one thing is that at fault network is कैसा होता है? All the three generators are considered to be in parallel. How much it is been given? All the three are having the 30% reactance. 30% here, 30% here, 30% here. Where the fault is occurred? On the bus bar. That means any point on this is the fault. This one is. Okay, so where you have to find the X equivalent, you need to find the X equivalent between the point of fault to the ground. So this is the X equivalent. So from this you can get it like this: X equivalent is equals to 30 by 3, okay, percentage. Then IF is equals to 1.0 divided by 30 by 3 divided by 100 is the percentage, no, into how much it is? 5248. So that is equals to 52480 amperes. You have to understand one thing is that one is the minimum IF minimum is double IF maximum is 12.5. This one is, इसको क्या बोलते हैं? VPF by Z equivalent को इसको क्या बोलते हैं? SCR बोलते हैं, शॉर्ट सर्क्यूट रेशियो. शॉर्ट सर्क्यूट रेशियो मिनिमम कितना होता है बोला था ना मैंने? 2. मैक्सिमम कितना होता है? That is equals to 12.5. Any fault current should not be more than 12.5 times. These are all the salient features, very very important. Okay, I am letting you have to note down all these things. Okay, in this the fault is occurred. Okay, then what is the equivalent reactance that what you can have is, right? Okay, here the thing is that one is take one thing as a base. Okay, select 10 MVA as base. Then what is happening here is this is okay, this is okay. Then Xg2 Xg3 equals to 12 into new is 10 and old is 15. This is equals to 8, and XR1 equal to 5 into 10 by 5. That is equals to how much? 10. So what I can say? Network under fault. Where the fault is occurred? Here. So generator neutral is grounded. This generator neutral is grounded. This generator neutral is grounded. It can have the common path with all these three. Then what is happening is it is equivalent to like this. Here the fault is occurred here. So I need to take the X equivalent from this point to this point. X equivalent here I need to calculate. Here this is 10, this is 10, this is 5, this is 8, this is 8. So the X equivalent is equals to this 10 in parallel with this 10 plus 8 in parallel with 5 plus 8. Okay, so this X equivalent, how much it is coming as 6%. Then MVA SC equal to VPF by X equivalent into MVA B. So that is equal to 1.0 divided by 0.06 into 10. That equal to 167 MVA. Sometimes it may be 170 also. That is also correct. Okay, I am saying one thing is that is एक सही आंसर है. अगर आप गलत तरीका से किया है तो ये सब probabilities होता है. Okay, I have not given the answers randomly. और कुछ गलत तरीका से अगर किया है तो हमने किस तरह wrong answers आता है वो सब मैंने इकट्ठा किया था. तो कोई भी आपका रॉन्ग ऑप्शन हमारी ऑप्शन से मैच किया है तो ओके ऐसा होता है कि आपको लगता है कि आंसर आ गया, लेकिन बात क्या है कि आंसर नहीं आया था, वो गलत है। तो इसलिए आप लोग को बार बार मैं बोल रहा हूँ, चीज़ को तो सारी ताकत से पकड़ लो, ठीक है। दैट इज द थिंग इज next is the sequence impedance of generators are given here. Then find the value of the reactance to be kept in neutral so that the fault level in the LG fault limited to three phase fault. Actually this has been possible under special conditions. Okay, so then what's happening is here it is IF three phase is equals to E by or EA by Z1, that equal to, you can write as a 3E by 3Z1. Okay, IF LG is equals to 3E divided by Z1 plus Z2 plus Z0 plus what it is 3Zn for IF LG to be equal to IF three phase क्या होना चाहिए, Zn equal to 1 by 3 into Z0 Z1 minus Z0. If make these two equations, if you both you made an equivalence, then what's happening is you are getting this equation. That means that one is 3E by Z1 equals to 3E divided by Z1 plus Z2 plus Z0 plus 3Zn. If you make this equivalence, you can get the Zn is equal to by 3 into Z1 minus Z0. So that is equals to 1 by 3 into J.5 minus J.05. So that itself is indicating J.15. Okay, normally what's happening is while you are making the description, the study of the fault analysis, you might have learned in such a way that one is LG fault is the lowest intensified fault when compared to any other fault. Okay, but here the LG fault is dominating on the three phase fault. The reason is that what is happening is the solid grounding and the fault occurs at the terminals. All these some special considerations are there, and one more is that one is Z1 equal to Z2. For the synchronous machine, what is happening is Z1 is not equal to Z2. Z1 is greater than Z2 for the synchronous machines, but here it is happening means okay, it is in the special case something like that. Next is that what is happening is okay, so IA1 equal to okay, so identify the fault is equal to LLG fault. Why it is being called the LLG fault is, if it is the LG fault, all the three should be same. For the LL fault, there should not be any zero sequence component, therefore it is the LLG fault. Okay, so what you can write for LLG fault, what you can say, VA1 equal to VA2 equal to VA0, that equals to VA by 3, that equal to 0.6 by 3, that equal to 0.2. और देख लो और एक चीज़ भी हो रही है, if you make that IA equal to, what is the difference, IA equal to IA1 plus IA2 plus IA0 is becoming 0 here. IA equal to 0 is the one boundary condition for this one is okay, so that is the thing is okay. So the one thereby what's happening is I have to go for the calculation of the Z1. Z1 is equals to what I can say VA1 minus EA divided by IA1, so that is equals to 0.2 minus 1.0 divided by minus J1.6, this is equals to 0.5 J.5. Z2 is equals to minus VA2 divided by IA2, so that is equal to minus 0.2 divided by J.5, so that is equals to J.4. Z0 is equal to minus VA0 by IA0, that equals to minus 0.2 divided by 1.1, so that equal to J.18. So this is the second bit. Find the sequence impedances if the pre-fault voltage 1 per and post-fault voltage this one is. Identify the system. Okay, third is as Z1 greater than Z2 greater than Z0. What it is? It is synchronous machine. It is a synchronous machine. ठीक है, this one is clear. See, point is that what's happening here is okay. So it is a synchronous machine. The reason is that what's happening here is in the synchronous machine Z1 greater than Z2 greater than Z0. If it is a transformer, Z1 equal to Z2, okay, greater than Z0. If it is the transmission line, Z1 equal to Z2 less than Z0. In the transmission line, the series sequence impedance is found to be more than the positive or negative sequences. Okay, so next is the power in production and switchgear. We are go for the protection. So here the questions are being very simple. Reason is that what is happening here is the subject of protection is aimed for the theoretical concern more. So that is the reason what is happening is numerical gestures are being the simple one. There are some topics are being the transmission distribution. They are being much more for the analytical approach. That is the reason conceptual approach is being the less. Mind one thing, subject is the theoretical one, at which what is happening is the numerical analysis will be less. Subject is a numerical based, concept is being the less. That is the reason in your control systems or network analysis, you don't have the much more concepts. You are having the more number of numericals, but in the power system is the mixed one. Okay, so a circuit breaker is rated as a 4 poles 200 MVA generator. Find the making current. So first of all, breaking current is equals to how much it is been. Capacity is how much? 200 into what is a 10 cube divided by root 3 into what it is a 33. So this may be equal to 3.5 kiloamperes. We know one thing is that making current is equals to 2.55 times of the breaking current. So that is equals to 2.55 into 3.5. So that is equals to 8.923 kiloamperes. It is a simple question. Making capacity is equal to making capacity equal to 2.55 times of the making capacity. Likewise, what is happening is making current is equal to 2.55 times of the breaking current. Okay. Next is a circuit breaker is connected to the 132 kV 50 Hz line. The natural frequency of oscillations is equal to T. Find the time at VR max. So what you can say that one is at VR max. Okay. So what you can say is time T is equals to pi by omega n. Okay. So that is equals to pi by omega means what is happening is a 2 pi Fn. So pi gets cancelled, 1 by 2 into Fn, natural frequency of oscillations is 25 into what it is 10 to the power of 10 cube. So this is equals to 20 microseconds. 20 milliseconds will come, that you are going for this one is minus 3, 20 microseconds. Okay, simple question. The derivation that you have to make it, because the thing is VR equal to V into 1 minus cos omega n into T. VR max is equals to 2V. So 2V equal to V into 1 minus cos omega n T. ये क्या होना चाहिए? Cos omega n T should be equal to minus 1. Thereby omega n T is equals to what it is? Cos inverse of minus 1, that is equals to pi. So T is equals to pi by omega n. This, I think this derivation that you have done in control systems also to get the peak time. Okay. The stray inductance and capacitance are find the critical value of the resistance to be switched across the terminals so that there is no transient. So critical resistance RC is equals to 1 by 2 into root over what it is L by C, that equals to 1 by 2 into root over L equal to how much it is 4 into 10 power minus 3, and this one is equal to 0.1 into 10 power minus 6. So it is coming as the value of 100 ohms. Okay, the resistance should be less than this one. If the resistance is more than this one, damped frequency of oscillations are being possible. Okay, a relay has the current setting of 80% conducted through the CT of 500. Find the PSM for the fault current of 400. So PSM is equals to fault current by pickup current. So this is equals to fault current, how much is being given? 4000. Okay, the pickup kitna hota hai? Pickup is equals to current setting is equal to 80%, 0.8 into CT ratio is 400 by 500 by 5, 500 by 5 into what it is 5, 5 gets cancels, this is equals to 10. Okay, so pickup current IP is equal to current setting into CT ratio into CT secondary value. Current setting is equal to 80% means 0.8, CT ratio is 500 by 5 and secondary value, CT secondary value is equal to 5. So, the PSM is equals to 10. The relay operating time of the 20 seconds TSM equal to what would be the time operating TSM? Okay, TSM equal to time of operation by time of operation at TSM equal to 1 second. Okay, so TSM is given the 0.6, time of operation you need to calculate, time of operation TSM is equals to 1 second is equals to 20. So, time of operation is equals to 12 seconds. Simple question. Relay the TSM second connected to the CT of this and for the fault current of 400 find the time of operation. Okay, here TSM equals to 4000 fault current divided by, okay, CT second, the current setting is has not been given what percentage. That is the reason what's happening is you have to take the 100% into CT ratio is 400 by 5 into CT secondary 5. TSM is equals to 10. Okay, for TSM equal to 10, the time of operation is equal to TSM is equal to 10 of the time of operation कितना होता है 2.8 seconds. Okay, so what it is, this is on TSM equal to 1 second. Okay, but this relay set TSM equal to 0.3 seconds. Therefore, time of operation equal to 0.3 into 2.8. So, that is equals to 0.84 second. Point 84 second. Okay. Next is the neutral of 11 kV generator is a 10 resistor. It is also standard question. See, in the alternator for accepting is at the bottom portion the maximum voltage is there, at the lower portion the minimum voltage is there. So that is the reason what's happening is it is not provide the insulation throughout the cross section is being the same. Certain bottom portion if you are not providing the insulation chalega, क्योंकि the air at this air can act as an insulator dielectric, that air insulation is being sufficient for that low level of the voltage. So that is the reason certain bottom portion of the conductors is not being covered with insulation, because insulation के लिए बहुत सारा खर्चा पड़ती है. So that is the reason what is happening is we are not making that one is. That means that you can assess like this. This is the phase that what you can have is, it is the phase and it is the neutral. So certain portion up to which this protection has been made, this is equals to x. This is what it is, 1 minus x. It is protected, it is unprotected. Okay? So at this regions, to limit the current, what you are doing here is you are providing a resistor here to limit the current here itself. Okay now? So this is the RF that you are making, and this current can be taken as the IF. So you can write like this, IF is equals to 1 minus x into V by RF. Okay? Voltage per phase is equals to 11,000 divided by root 3, that equal to 6351. Then what is happening is here it is IF is equals to how much has been given 0.6, okay, into what it is, the 500 by 5, that is equals to 60. So equation will come like this, 60 equal to 1 minus x into 6351 divided by 100. So sorry, 10. This is equals to 1 minus x is equals to 0.095, that means 9.5 percentage. Okay, this is the standard question, very standard question it is being. Okay, so in many examinations it is appeared, this one is certain portion at the lower portion. What is for every question what is happening is I am not limiting myself to the question, I am giving the concept also. What is the reason to handle this one is, and one more thing I am saying, that one is this answer 1 minus x should come in between, should be 15 to 20 percentage. What does it mean? It is not that one in between 15 to 20, up to 50 or maximum up to 20. That is the meaning of that one is, okay na. It is 15 to 20 means it does not mean that one is it is in the range of 15 to 20, minimum 50, maximum 20, up to 15 in general way, maximum up to 20. That means 5 to the 20, 15 to 20%, that is a grace. Okay now, transformer provided the differential protection, CTs on the LV side is equal to, then what would be the CTs ratio on the HV side. You see, one thing is that one is, here the transformer is being given that one, the star delta, this is the star and this is the delta, this is the primary and secondary you can take, this is the CT1 and this is the CT2 you take it. CT1 to be connected in delta, CT to be connected in a star. So here it was said that current is equals to 500 here. So here it is what's happening is CTs are connected in delta now. So how they are connected? In delta the connection means here you can assess the connectivity like this. So that means that what is happening is across this it is equals to 5, across this it is equals to 5. Through this pilot how much it will be coming as 5 root 3. Okay, here what it is being, it is in star connectivity. Okay, so what I can say here is this is going like this. Therefore, what is happening is CT2 secondary equals to 5 root 3. Okay, we know one thing in the transformers, root 3 V1 I1 equals to root 3 V2 I2. So root 3 into 11 kV, जल्दबाजी में ना गलती ज़्यादा होता है. 11 into this side is equals to how much? 500. Okay, equals to root 3 into what it is, 33 into I2. So from this I can say I2 is equals to 500 by 3. So CT2 secondary primary equal to 500 by 3. So CT2 has a ratio of 500 by 3 of 5 root 3. So that is equals to 500 by 26. This is the right answer. Okay. This is also one of the standard question. Okay. Next. So here it is another, both the CTs are of the relay set with the 0.5. For the occurred fault, the relay does operates or not, yes. So the current coming through this one can be taken as I1 minus I2. So क्या होना चाहिए? I1 minus I2 must be greater than 0.5. If for this fault, if the differential current is more than 0.5, then the relay will operate, otherwise relay will not operate. So estimate the I1. I1 is equals to how much it is? 360 into 5 by 400, that equal to 4.5. I2 is equals to 300 into 5 by 400, that equals to 3.75. I1 minus I2 is equal to 0.75 greater than 0.5. So relay will operate. If it comes less than 0.5, relay will not operate. Okay. These are the certain questions that you have to prepared. Okay, then what's happening is you can acknowledge me in that one is somebody asked me this, how to contact you. This is my number 9849275397. Okay, this is my number. Anyone can make a contact to this number. Okay, so normal छोटी छोटी question हो तो WhatsApp करो. अगर लंबा क्वेश्चन होता तो मेल कर देना limu@yahoo.com. These are to my credentials and contacts, contact info. Through this you can make it. Okay. So again I am saying the same thing is that one is, so through the power system, okay, from the all the topics, what is the data type that can present? According to the data type what is being presented, as per that I designed these questions. One more time you can have watch this video and note down the things in a proper manner. So do well, all the best. Okay, so at here what is happening is the time is running off. I cannot speak more than this one. Okay, so all the best and you can go through this one. Is the maximum work. Okay, आपका 3 घंटा के एग्जाम होती है. 3 घंटा में एग्जाम में कितनी क्वेश्चंस आपको सॉल्व करनी है? 65. So therefore what is happening is okay, Joy, I have already given the number. Okay, you can note down. थोड़ा टाइम लैग होता है. Okay, इसमें देख लेना. So I am saying one thing is that what is happening is, okay, so according to that I designed the questions. आपको तो 3 घंटा एग्जाम होता है, 3 घंटा में 65 क्वेश्चन लिखनी है, इसलिए तो मैं भी इस 3 घंटा में 65 क्वेश्चंस I prepared. Okay, whether you know it or not I don't know. In this 3 hours we did the 65 questions. Okay, so thank you very much. I am saying one thing is that what's happening there is you can yes, सब क्वेश्चंस हो गया. मैं आपको एक चेतावनी देता हूँ. Thing is that what's happening is if you concentrate these questions it is sufficient. I'm saying on the last minute preparation में आप एग्जाम को जब जाते हो ना, ये क्वेश्चंस देख कर जाओ, काफ़ी हो जाएगा. These are sufficient. I feel that because all the models, these are all the models. So thereby what's happening is सब की सब models मैंने करवाया था. ठीक है, अगर कोई डाउट वगैरह हो गया तो वो क्रेडेंशियल्स दिया था ना, नंबर एंड फ़ोन नंबर एंड मेल आईडी दिया था ना, उसमें कांटेक्ट करो. सो देयरफॉर व्हाट इज हैपनिंग इज आई विल बी अवेलेबल ऑल द टाइम. ओके, सो हर दिन मुझे रात 10 बजे से लेकर 11 बजे तक, 1 बजे तक स्टूडेंट्स के साथ उन लोगों को मेल्स क्लियर करना, व्हाट्सअप क्लियर करना, वो सब हो जाता है. सो देयरफॉर इफ एनीबडी हैव अ डाउट, ओके, यू प्लीज रेंडर ऑन दिस वन इज, ओके, टेक द एडवांटेज ऑफ दैट नॉलेज. सो ओके, तो यही बोल रहा हूँ, बात ये है कि सो सब क्वेश्चंस हो गया. ऑल द बेस्ट, यू कैन डू वेल. ओके, ऑल द मॉडल्स we I covered. So in the conceptualization of the power system, what type of data is available, by making use of the data, what kind of numerical analysis that you have done, I have done it like this. Okay, so some kind of a conventional questions in a regular class we used to do. In the interest, in the favor of IES students, we have not done. It is not necessary also. So therefore what's happening is, okay, thank you very much. All the best for your future.